Hello everyone. How is everyone doing? We're continuing with SurrealDB benchmarking today. And a lot happened since then, because I did actually run some benchmarks here and there and kind of prep the system so that we can do a bit more of actual benchmarking this time, because last stream was like we barely got off to a quote-unquote benchmark. This time we'll be able to focus actually on trying different things and focusing more on querying rather than flooding the database with random records or anything. So yeah, I actually have a few benchmarks running at this very moment, but these are the SurrealKV benchmarks, so they're not going very fast. Let me roughly show you around. Maybe first the results that we had since last time. Okay. I'm just going to copy the link to it, or maybe simply do this. Okay. There we go. So this is the document that I shared everywhere. Probably in the link to the previous, in a comment in the previous video as well. So I finally got to run everything on all 4 machines. We have from the slowest to the fastest. Although notice that they are all running inside Docker containers. So to some extent, this is not utilizing full power of each machine. Because if I run it on my laptop right now, Docker shows 100% CPU usage, but my machine says, 20, 25 or something like that, right? So in theory, I'm not using it to the full extent. Probably just a little bit, the few cores or whatever. And these 2 machines are really, really, really slow because they have very underpowered CPUs, like Celeron N5105 and some mini PC, or AMD Ryzen embedded, which is an ass. So, that is a big limit here, but it kind of shows us, how the thing runs on something really slow, how it runs on something fast. And therefore we can kind of have a comparison. And at the same time, we're running it on, here we're running it on ZFS with 8 hard drives and a 3rd generation SSDs, PCI 3rd gen or whatever. So something slower to something faster. Not the fastest and not the slowest, but we've got something. And we were working on the first one. That's how it's called, this quote-unquote benchmark. That basically what it did, it was, hey, let's create 50,000 random records, grab all the data from them without any normal, any trick in there. Just grab it all, delete it all, remove table, and start over like 50 times. Which is totally... I wouldn't call that a benchmark. I don't know what the hell it benchmarks. It's just not realistic. Nobody does that really. So this is kind of pointless thing, but it was something we could run, something that showed us, how those things differ. And this table is divided where we have basically per each instruction, because this is, there we have schemaless variant and we have the schema full variant. Okay. And maybe I can do F10 or 11. There we go. So schema less variant just doesn't define the fields. It just defines the table and that's it. And schema full just defines the fields. So in addition, when creating, or when pretty much probably only creating, when creating data, it just checks if tabs are correct and that's it. So again, this is a pointless test. This is nothing good. But, we went through that, and we have data for each variant of the database. 1.5 running on RocksDB and in memory, and then we have 2.0.1 running on RocksDB, SurrealKV, which is in beta/alpha, and in memory. So if all those variants tested on all the devices, notice that Java didn't even complete this test 10 times on SurrealKV due to current problem with with deletions. I believe in the next patch of SurrealDB in 2.03, this will be fixed, and we'll see some improvements. But at the same time, SurrealKV isn't just data store; it's also a log. It keeps versions. It does a lot more stuff. It's a different kind of store. That's why we have them to choose from, right? And this is also beta/alpha. It's just it's gonna be changing vastly, and we're building tools to be able to benchmark it and compare how it changes over time. Okay. And today I also started running tests for the new just release, I believe just today, SurrealDB 2.0.2. So not a lot changed there. A few things in the backend, few things were caught, few things were fixed. I believe just there are a little bit more checks, and that's why we have some differences. So for example, for RocksDB, we can see that on those weak devices, it slowed down by 0.6%, which is, within margin of error. Maybe today is a bit warmer than last time, and because of that, devices are running slow or something. Although Homelander, the better one, just noticed nearly 3% performance increase. So that's interesting. And when it comes to SurrealKV, I haven't run the tests fully yet, at least. And in memory, we have again mixed bag, plus minus 2%. It's random. Okay, so everything stayed the same, so that's good. And as we speak, some more stuff is running. So that's for the schema less. Well, for the schema full, we have exactly copy thing. And again, we have exact same results where it's just random. Okay. I also added a column, which is basically average of. So that's what I was looking at. We have averages of all the times for that query. And I'll be probably following with similar tables for other stuff. Just so that, we have some kind of one number to look at instead of always looking at all the numbers. And then I also take an average of all the devices. Okay. And this way we kind of have a little bit more of a picture of overall, like a one score for this storage layer for that version of the database, right? So we can see that, for example, scores are nearly the same. I mean, here the lower score the better. And therefore there's not much to compare from 202 or from 201 to 202. And then we have first actual proper benchmark that I made. It's tombstones. So what's the description I gave it? This benchmark measures how the performance degrades when a lot of records are being created and deleted repeatedly. So the thing is that in SurrealDB, you have two separate layers. One is the compute layer that actually does all the calculations, how the data goes, where it goes, and whatnot. And then you have the second layer, which is the storage layer, which could be changed, swapped whenever you want. You can change it to something else. And something like, RocksDB or maybe SurrealKV, or if you need to have it distributed, you go with TIKV, right? You can change those backends for storage. And the way those key values often work is that when you delete something, it doesn't mean it's instantly deleted out of your drive. Maybe it stays there, maybe it's marked there, maybe something it overrides it, maybe it has some functionality that allows you to restore it quickly at some point. I have no idea. There's just lots of stuff going on there. But what basically happens is that if I will take one query, right, and let's say the creation and deletion, it's just create 5,000 records, right, with some random numbers and text, okay? Just like that. Just create a record, and then delete it. Okay. And this is wrong here because this actually should be like that. It works properly in code. So, you know, we create and delete them. So the thing is that the moment we created 5,000, and even though we deleted them, there's some left over there. Therefore, the next query goes slower. Next query goes slower. And slowly it degrades because maybe hashes are used up because I'm creating just from with IDs from 0 or whatever, from 0 to 5,000 or something. And they keep overlapping. Maybe hash maps get, you know, a little bit polluted and whatnot. And basically over time, you know, when we start, for example, on Vision, on a modern laptop, creation time of 5,000 records, 56 milliseconds. Okay, all those numbers are in milliseconds. By the time we finish, after 100, we just did times 10, right? And this is not due to how SurrealDB manages the data. This is purely because of RocksDB, how RocksDB manages data. Because when we go to in-memory, you can see that creation took that much time. At the end, it's still the same. It's flat. It doesn't change. So it's purely from the storage layer. And right now, SurrealKV, you know, isn't happy about that. Creation is fine, but deletion is fine. But like I said, they're fixing that. So soon enough, we'll have something that works a little bit better. And I run those tombstones for everything but the SurrealKV, also for the newer version. And I haven't gotten too much comparisons, but what can we say? Pretty much the same. Yeah, pretty much the same. Numbers go faster, slower, whatnot. So this one actually has some diagrams, okay? So again, I can actually probably grab this file. What is it? Share. Let's copy the link. I'm gonna put in the chat in both places just in case, and I need to remember to add it to the description. Let's call it results, and bam. Okay, it's a YouTube video description as well, so you can go and grab it. So this is basic creation time, degradation over time. So you can see that we have two lines, and they are pretty much the same, no matter what. The only standout is SurrealKV, which for in-memory stays the same. It's just a little bit offset, right? I mean, it's not even on the on a creation time for... Wait, this is creation time, right? So everything is here. We can see that between versions, no matter if it's, you know, the blue line for 1.5 or for, you know, 202, they're all the same because here we're purely testing the storage layer. And when it comes to degradation time, when deleting, I guess, involves a little bit more than just creating because we have those things left over. And we can see that here where, for example, SurrealKV, at least as of 201 and 202, doesn't even fit the first record because it goes like to few seconds initially, and then it goes to like, you know, what are the numbers actually? It goes all the way to 14 seconds per record. Yeah, so it takes a bit longer than 800 milliseconds compared to other things. But again, you know, it's pretty comfortable. We can see that, you know, no big deal here. So the goal for today is to actually develop a little more benchmarks. But as we speak, I have more of them running in our test runner. So they're still running here. Maybe by the time I'm finished describing how our project is structured, some of them will finish. Okay. So let me just show you a quick introduction to how the project is structured now and how we're running those benchmarks. And a disclaimer here, I'm by no means somebody that knows about benchmarking. I'm definitely not somebody that, I never did any serious benchmarking. I'm just doing my stuff. Stuff is running in Docker, so it's not the most optimized. And I'm also, I don't know as much about how it works in the backend, the SurrealDB internally. Therefore, I'm kind of, poking around and playing around, seeing if I can get something meaningful out of it. Like last stream, I learned that, there are tombstones, and the more you fill with storage layer, the slower it gets. So, moving forward. This is a simple bun project, or Node.js. You could probably run it, no problem from there, although I'm using a few things from bun. So what we're doing here is we have some things for where we're storing where and how we're storing the results, as in, we have results from when they create themselves in a folder, and I push them as those raw files to the repository as well, so that if somebody wants the actual, like I go to Homelander SurrealKV, first one, the benchmark is first one, then we've got in the name that it's SurrealKV, schema full, and a summary. So we have a summary file, which is kind of like a quick little thing, and we have the actual data, which is all those points, which is more interesting for something like the first one, which is way more data, right? While the summary is a little bit more brief. So, if you really want to dig into that, the code is available and results are all here. So, yeah. So we have an idea of a plan. Okay? A plan is basically a name, because it would be nice to have a name. It's a list of databases and what benchmarks to run on them. And to not over-explain things, it looks basically like this. Right now, you can see that I'm running a plan named Translucent, because that's one of the machines, and I run this plan on Translucent and Vision and Homelander, on those 3 devices. And they all use a set of Vision set, which is basically a set of databases, because on each of those devices, I have deployed 5 versions of the database, like I was mentioning before. And because I'm running the 5 of them on each server, I want to go only one of them at a time. So this ensures that, for this plan, I'll be running it over those databases one by one, benchmarks one by one, but only within that machine. But what it allows me is that when I start it, it's gonna open 3 connections to those 3 databases, and just keep chugging those 2 specific benchmarks over them. So this allows me to quickly configure, switch things on and off as I want to recheck and whatnot. And at the end, we just have a way to run a plan, which is basically go over all the plans and start running them, and just wait until they all finish. And that's it. They all run asynchronously. So we basically go for each plan, for something like things are defined on Homelander, we just go over each database sequentially, not concurrently, sequentially. That's the important part here, because they all run on the same machine. And then what? We go again sequentially over the benchmarks, and we just run the benchmark, mark that it's finished, write down all the results of the benchmark, basically all the data points that we got. And additionally, I have a short summary that summarizes it, averages out data from all the iterations, because each benchmark can be run multiple times. And that's it. That's how we go over them. It's that simple, nothing crazy here. So as an example of some kind of more in-depth, we can go over to the idea of a database. And you can see that database is basically name, IP, and port. And I have some hard-coded shared username and password just for testing. And I have just extra function that generates all the variants of databases. Right now, I want to test only the SurrealKV, so I commented out everything else, and this is what is running there in the background. And I just decided, okay, here generate me those sets, all the variants of the database, which is right now defined as only one, for each of the machines, and I'm using them, an index to specify which benchmarks run where. And then we've got, of course, the idea of a benchmark, which is just a bunch of types, things like iterations, number of connections that's not implemented yet, and a benchmark runner, which I don't think I have touched at all since the last live stream, so no need for me to explain anything here, I believe. Code is pretty straightforward. So how does the first one look? The first benchmark. So right now I'm running it as 10 iterations just for SurrealKV, so I can finish it within a few hours rather than within a few months. We have our query, okay, no big deal. And we have basically, I just extracted a few things as separate tasks. So we have, for example, first one, schema-less, which namespace to run it in, what's the name, and list of queries, which is, first one is define table. Second one is the one that I defined up there to perform the test, which is reused for all of them, and cleanup, and, however many iterations and whatnot. And then we've got the schema full, which is basically the same thing. The only thing is, instead of being just define table, we have those three here. Like I mentioned, that was a pointless test, but it allowed us to automate some stuff. So the more interesting one is the tombstones, where you can see that we defined that it will be 100 repetitions, how many records per repetition to create, and yeah, definition just goes here. These are the queries. Only one iteration because I need to restart the database and clear all the data between every runs due to this. And then what? This is just generates the queries. So yeah, run it 1,000 times. That's it. So we literally create a list of 1,000 queries, and that's it. So that's how it's run. So that's that. And I think that explains everything, I believe, at this point. So we've got things running. Things are running on SurrealKV, on Vision. It's literally the last iteration. So I can look at some results that we got from this specific run. And it looks like I've already got some. So we can fill out the schemaless SurrealKV for first one, schemaless. So the way I do it is just copy the stuff from the summary, which are averages of 10 runs in this case. So this is the Vision schemaless. So we go to first one, schemaless. So it'll be here on the left, schemaless, Vision. This is the newest 202 Vision. So I'm gonna paste it here. Bam. These values just need to move here. And we can simply decrease the number of after comma. And we've got our result. And performance degraded 15%. But again, this is a very small run of just 10 repetitions. So not the greatest one. Not sounding reliable. So that's that. And what other runs do we have? We have, wow, one device didn't even finish them yet. Holy moly. So Homelander, schemaless summary. Okay. Homelander, schemaless. Bam. And we move those here. And wait. Okay, now it looks a bit better. Okay, and we just do that. And here, for some reason, performance improvement a little bit. So like I mentioned, this is not the best thing to rely on, okay? It's very unstable at this moment. This benchmark. And then we have schema full summary. Bam. And therefore we can go to schema full. SurrealKV for Homelander, we just paste it in. Okay. And this one. There we go. And here again, improvement of 3% out of nowhere. So this is pretty random. Again, it's just 10 repetitions versus 50 for all the other ones. So yeah, and this test also includes massive amounts of this degradation, because here we're creating just 5,000, right? Here, every iteration is 50,000. So this is the worst possible test for everything, because it's just put things on top of each other and too much randomness in there, okay? So that's why now we can think about implementing something more interesting than this. So I actually haven't had a chance to think about it too much because I was busy doing stuff here. So did we get a new result? While this is running, we're gonna define more tests, okay? I'm just gonna have it here running. So what kind of test could we run, I wonder? So the database is either about storing the data, right? Or about retrieving data. And with SurrealDB, we have also ways to, guard the data or propagate updates here and there, okay? So maybe we'll focus on something simple. Maybe we could define some kind of simple data set, okay, that we can load up or like generate. In my opinion, it would be nice to be able to generate something and then run some queries against it, okay? Like a set of, maybe we could actually make something. Yeah, that's a good idea. Let's make it so that we have somewhat comprehensive set of data that we generate initially through code. And then after that, we start the actual test and have tests for various different aspects of the database, okay? And because of that, we'll be able to, gather some more data. So let me think. Let's maybe write those things down quickly. So what things would we want to basically test or do things? So I won't be doing a lot of data insertion benchmarks right now, because I don't know what's the point with that at this very moment. But what I would like to do is basically, basic selection with simple where clauses, okay? Just something simple. Then it would be nice to have a selection with more complex where clauses, right? How does this change performance a lot? Maybe selection with subqueries, okay? Or maybe selection with nested or like against nested values. That's, is it bad? Or maybe selection that returns lots of nested data. Because again, in SurrealDB, you don't have to do the joins. You just do dot star and we'll return everything inside. So we could probably push that a little bit more. Then I would like to have basics of, querying relations. As simple. Then I would like querying relations with where clauses, because you can put where clauses inside there. And what else could it be? count. Okay, that's another massive subject, count or order by. And then we could, test various data types. There's just so much that we can test, right? It's just, you can probably write thousands of various tests. And we are not going to do that, at least not yet. We're gonna just try to figure out what kind of data can we specify so that we can start testing it. And I'm tempted to literally do something that we were kind of doing when designing the blog, the blog and comment system schema, because that involved few interesting things, because we had not only some complex querying with additional, we had asserts, we had default values, we had events that modify data, we had view tables, right? We had all those complex things. I won't be doing any permissions and user stuff, because that means I will need to set some of the database a little bit differently, probably create some things on the go, and maybe not for this live stream. But this kind of sounds fun, right? Yeah, let's try to do that. Let's try to set up something more complex and see if we can even learn something with that. Okay, and this will give us some kind of starting point as well, which I I'll be very happy about. So let me think. We can probably just go and open it up. Okay, because I remember this was Learning Surreal. There we go. That was the project. And we have all this stuff here. This is, a lot. So let me think what we could actually bring in. Things approved, authored, comment, contains, all the things. So let's start with the content itself first, right? Because we have post, we have a series, topic, all those things. And I believe I still have a diagram. So maybe we're gonna grab the diagram, simplify it a little bit, just so that we can actually, achieve something. Or maybe not simplify it at all. Where did I have it? Here. So let's go to Excalibur. And do we have anything here? Yes, we have exactly the thing that we need. Perfect. Alrighty. So we have our topic, series, and post. And then we had the additional post interactions, which is a view table. And we had users, and we had comments. So this is not a lot of tables for that. But we had lots of tables for relations, which is a big part of it, okay? Because most of those links are actually done by, with tables. So maybe we could actually make it so that we recreate the whole thing and just keep running tests against it, because this part, dealing with posts, series, topics, and possibly, simple querying and creation of comments or posts, that should be relatively easy from the perspective of the system user, right? We just won't run those permissions that we had defined, won't be running there. But later, as we're developing the series of tests a bit more, we can actually add, hey, log out of the database, log in as this specific user with this specific data. We can modify the access at some point to make it accept, some randomly generated password or something, or hard-coded password just for testing. But as long as it's gonna, the login itself, that's not a performance issue. But then we'll be able to actually see and test how this whole model works from perspective of users. We can even make it, let's imagine there's 50 users. We open 50 WebSocket connections and just start doing stuff. So how do I bring all this data into here, into our project? Because we have all those queries, right? we have the whole schema here. I wonder if we can just dump this whole schema into one super long file. Okay. I think we can. Because we don't worry about AstroSync, you know, the more complex stuff. That's not really necessary here. So let's look at that. We have access to specify, so that's one thing. Approved, authored. Okay, sure. Let's do that. So I'm gonna put it side by side. And this one and which one? Too many windows. This one. So what I'm gonna do is in benchmarks create new file, and we're gonna call it what could we call it? Mixed one. Because this will be a mix of various things to test, okay? And we'll see how the database goes through that, which parts take how long. Mix one underscore data. Or like schema. The SurrealQV. Okay, so this will be just our way to store all the things. So yeah, let's start with access. For now, we have this access defined as if you needed this whole thing, it's just gonna go through it and we can ignore it, okay? Because we'll modify it later. Then we've got the, well, let's make the user, okay? Then we have user, and what kind of things did we have here? I'm gonna make the font a little bit smaller here just so I can quickly orient myself to see if we're not putting too much or whatever. Username, email, author, created ad, updated. Okay, all this fun stuff. Sure, that's fun. We can always take it out of here. So let's just add a simple something like access. Then we've got the user. Okay. And I guess we're supposed to do double dashes here. That's how Surreal likes to make comments. I'm just gonna make it like this so that we can quickly see it and override it. So this would be user. Then we're gonna have, we'll just go with something like approved. The nice thing about definitions is that they don't really necessarily depend on each other, because they can reference things that don't exist yet. It's just a reference. I mean, just a definition, so that's good. Okay, we got approved. We've got enforced relations, overriding. I mean, the note. Only one approval comment, all that stuff. The thing is that I want to delete all the overrides because the idea is that we're setting it only once, right? So if there's actual problem with something, like we're trying to do something twice, at least we're gonna get an error and know a little bit more about our test, that hey, our test, there's something wrong with it. So we're gonna have approved, then we're gonna have authored, and I'm just gonna copy a bunch of those so that we can quickly copy paste. So authored, that was relation which user authored a blog post, right? Then we had comment. That was the more interesting one. That basically defining comment. And here we have the more interesting parts where, for example, besides permissions, we have fields like when comment is created. We check if the posts exist and all the other things, you know, the IDs are fine and whatnot, or when it gets approved, we automatically update, you know, the comments count on other things and whatnot. So this is an interesting one. So this is where we will be able to see, you know, how the performance changes a little bit more real, like, you know, on a schema a little bit closer to something that could have been used in real life, because that's what I was designing, something that I will slowly be implementing on my own blog, right? I already have data syncing and all the other stuff. I just need to work on the interface now. Then we've got contains, which means that a series contains a blog post. Okay. Then we've got basically is about, and this is for both that the series is about something or a post is about something. So these are the simple relations, the easiest ones to deal with. Okay. Then we've got learned, which is simply that user can mark a blog post as learned knowledge. We've got that somebody can like something, so it will be liked. And then we're gonna get post interactions. That's the one that we'll actually put at the end of everything, okay? Because this is the view table, so for it to work, we actually need to have at least the table defined from which we're pulling. Or I don't know what the hell happens if it's not defined. I actually haven't tested if it breaks or anything. So post interactions, so this would be post. And post just takes wait, this is post interactions. I want post. Okay. The post itself. All right, there's lots of data here, not a lot of logic, okay? Well, on delete, just it marks itself properly and does some other things, so that's that. And then we have requires. So this is where post can point at other posts that it requires that knowledge to be understood fully. We have an idea of it. Series of posts. Okay, there's a lot of little bits here. Test data, we don't worry about that yet, but we'll use it to generate our stuff, right? And the nice thing is that we can actually generate our queries with JavaScript, which will make it a bit easier than doing everything purely inside SurrealQL. And last two will be topic. Actually, the last one here. Topic. Okay. And then we'll have the post interactions because the user is already defined as first one, right? After the access. We have access and then user. Yeah. So we go down here. Oh, this is only what? Not even 700 lines, so not bad to be honest. 656 lines, that's it. Okay, so that's our schema. Great. So we've got the schema. So we can minimize that for now. And what I would like to do is just have some way of just saying, hey, you know what? Before you run this test, do this or something else, right? So why do I have extensions? We want this. So this is the mix one schema. Let's just create a new mixed one .ts for our actual benchmark. And I can just grab stuff from here and we're gonna continue on. So for mixed one, we just want to have the benchmark definition and the query definition, and that's pretty much it. Although something tells me we'll redefine those a little bit just so that we have a little bit more flexibility, because it would be nice to be able to say, you know what, now I'm gonna run those 15 queries or something. I know, we'll see. Okay, all right. That sounds good. So now, well, we're gonna say first step is load the stuff, right? But the thing is that when we look at a benchmark definition, it's just name, namespace, and the list of queries. So I would like to have also set up queries, okay, and a definition of queries here. And what I would like, the way I would like it to work is that when we run a benchmark, no matter how many iterations it has, it's gonna run the setup queries once per all those iterations. Argo would be nice to add a flag. Something like setup. So we have benchmark setup queries. Let's do that. And then it will be iteration setup queries. Okay. So let's have those two. The benchmark setup will just run once per benchmark, while iteration setup query will be run before each iteration. And the whole idea about those is that they are not included in the results. So it doesn't matter how many times it took. And let's also do benchmark teardown queries and iteration teardown queries. Okay, so that we have some kind of something that we can run also after the thing. Great. So now let's just add hooks for that and go for it. Okay. So our query definition is right now name and query. I would like to make it query or how are we running those? That's a good question. See, I forgot. It was just a week and I already forgot. Run benchmark. We give it a benchmark database and what it does here. Wait, and benchmark. Oh, we don't have any logic here. That's why. So all the logic is here. So run benchmark. We create thing for results. Run each query from benchmark. So we run all the iterations. So let's create an array of benchmark iterations. Basically, iterate over all of them, right? And we just have a number. What is the point of doing that instead of normal for loop? I have no idea. I guess that was AI suggesting things, and I was like, whatever, I want it done. So we basically every iteration create a new connection with the database, connect, and do this stuff, right? So this basically use sign in and whatnot. And only then when we are connected, we run the iteration, which will be iteration results. And for each query, we just run things. Okay, we just call run query. I see. So I wonder if we could make it so that we grab the query, right, from the queries. And depending if this query is a string, we just run it. If it's not a string, but it's a function that returns a string, we just call that function. And that's it. So I'd say that could work. Yeah, that could work. So let's... Because I'm already trying to think ahead, because I know that at some point, because we'll be using lots of random to generate random data. And also when running queries, it would be nice to be able to just query random data instead of hard code, 10,000 values or something. That would be no point. But when using random, things stop being repetitive. Unless you were talking about massive number of data points, which I don't want all my machines running nonstop. I can afford only for them to run here and there, because usually they have different jobs to do. So it would be nice to be able to have things run still randomly, but due to some specific seeds. So every time we give it the same value, it's gonna run the same way. No matter how many times we repeat it. So the thing here is that if I'm gonna make it that, run this query and get next string, during that get me next string, it could be simply a problem of that I'll be running 3 different, running requests to various different machines. They will be completing things in different order because each runs at their own pace. And suddenly I will have problems with random numbers, basically. So the question is, how could I prevent that? And I see an option to actually prevent that, which would be that when we run instead of run query, it will be, in case query is a function, and we're gonna say, let query string is, and we basically do the query, right? And we're gonna get a string, the next thing to run. But in our case, we will be able to provide it, hey, this is actually the thing number 1254, okay? And that could be, let's say, the number of iteration, or the number of those queries within here. So this is not that obvious how to actually perform that. Let me just get back here. So we have basically a database set or plan, okay? Which is database set. So within that, we have basically a database against which we run the benchmark itself. So let's say we have 5 plans, each one has 5, we have 4 plans, each one has 5 variants of SurrealDB, right? So we can just do this. And then, so let's actually know that we have 4 database plans. 5 databases, and we run, let's say, 10 benchmarks. And then each benchmark has, let's say, 100 iterations. And then within each iteration, we have, let's say, 20 queries. Okay, so that's how this number grows. So we would want to have repetitive number to basically go off here. So we could have something like, we could just start multiplying, right? Possibly, I think. There's probably a better way, but I would just go with multiplying. So multiplying plus maybe something or whatever. So let me think. That means, yeah, I think that could work. Okay, so our query will always take one number, which is like the ID of iteration, and then we'll generate maybe some kind of table of, I know, 100,000 numbers from 0 to 100,000, and we can module against that, and each one will have like pre-generated random number. So we pre-generate those random numbers once, and then we have basically some kind of table to take those semi-random numbers from, and number like 10,000 should be good enough. So I'm gonna create that quickly. Yeah, it's like a custom implementation of that. But I wonder, can we generate random from a number? I'm just gonna straight up ask Claude. I'm working with JavaScript. Can I reliably generate a random number depending on an integer or something. Consider it a seed that I can specify every time when calling for when getting the number. This way I can make my tests reproducible, if that's the good word here. So I just give it a bunch of words, right? So seeded random is constructor seed, and we have the seed. Oh, this basically asks me to do the thing myself. Seriously. Okay, so math random doesn't support seeding. You can implement a custom. Okay. Do you have any existing libraries that do that? Which you can recommend? This is Node.js. Okay, so that it knows that I'm using npm. Seed random, random.js, chance.js, and that's it. Okay, let's just click through them. So seed random. Seed random requires random. Oh, require. What the heck? Create a seeded random. Okay, so this is about creating seeded randoms. I see. Random numbers between 0 and 1 and all that stuff. Okay. Don't like it. Random.js. Again, create a seeded one. And chance.js. Create a seeded again. Okay. Oh, we can create a strings as well, and names and dates. Ooh, I like that because that means we could speed up generation of our data. So random.js or chance.js. Well, let's take a peek at both of them. Random-js library. Okay. Is it on GitHub? We have chance.js. There we go. They popped up quickly. And random.js. Last published 5 years ago. I know it should be fine, but weekly downloads is high. Okay. This one got 602 stars. And how about our chance? It has even fancy website. Ooh. We have basics, full falsy, floating, text. Ooh, I like that. We can quickly just get our stuff generated, and that's it. Okay. All right. Okay. Do you have like a GitHub or something for this thing? Random strings, numbers, blah blah. MIT license. Just link there. Website, usage section. It's all in here. Contributors. Okay, that finally links us to the GitHub. Wow, 6.4K. Okay, we're going with this one. All right. Me like that. Should work. Okay, so how do I install it? Install dependency. Wait, contribute? No. Okay, we need to go here. All right. Node. Oh, just chance. Okay, sure. So let's go here. Gonna go to our package.json, and in dependencies we're gonna say chance. Okay, and what version do we have available? That's the newest version. I'm just gonna lock it to a specific version, so in case between versions there are some inconsistencies introduced, and this way, again, we'll have things very reproducible. Okay. Okay. So, this is still running? This is still running. So in the meantime, I believe I have another result, right? Oh, I have two results. There we go. So we have vision schema full. Okay, the vision schema full. So the vision is done. We're gonna go to our thing here. First one, schema full for vision. Okay, there we go. Slowed down a little bit for vision. Interesting. 6.5% slowdown. It's so random. And translucent, I believe, got its first result, and we're gonna ignore the rest because I just don't have time to run it. So this will be translucent schemaless summary. Okay, so we go to schemaless translucent. There we go. There we go. So our benchmarks are just a little bit more complete. Even though this benchmark doesn't matter much, but I just rerunning it just to see how it compares to the newer version or whatnot. Which compares pretty much the same, so that's good. And this one didn't install much for some reason. Okay, great. So that part's done. I can stop this thing and just do fun install to get our chance. Great. So let's look how we can use it. Associate chance so that can be used and use it here. Okay. So I think I will be using it in a way where every time I'm just gonna make a simple wrapper around it so that every time I call it, I need to provide that seed, that special number, and from that we'll be generating new things, okay? This way we can kind of get things a bit more properly. So inside our benchmarks, I'm not going to touch it yet, but we need to make it so that we are propagating those IDs down the line, okay? So I would start it from all the way at the end, okay? We can get the results for now. I'm actually going to quickly start pushing those changes because I don't have them pushed yet. So the way I'm going to do it is, first of all, this stays the same. What's the problem here? Tombstone's benchmark. Wait. It's missing default properties. Oh, because we just redefined them. Oh, whatever. Let's go here to serial benchmarks and benchmark. We're not pushing that first one. I'm not pushing that change. I can actually discard it. We're not doing anything with mixed one. Database. We're gonna clean it up in a second. Index, we're gonna clean up in a second. Package.json, we are not modifying. But what we are pushing is all the results. Stage the folder. Okay. So let's just clean up our database because I want to uncomment everything on when we push the repo so that, you know, it stays the same. And then we're gonna have the what is it? Just index, right? Let's just re-enable everything. so that it all looks the way it's supposed to. Okay. Atom tones. There we go. Okay, now it's all clean. Everything's enabled. Great. So I can push the changes. Database and index. There we go. So this will be update v4 stream test 202. Okay, because we actually did those tests. Great. Okay. So if that's the case, we're gonna continue on. Let's close all this down. So we were touching on this thing where we can actually run those queries. So I'm gonna revert that so we don't have any unnecessary errors right now. And inside benchmark, let's make it that the query definition is either a string or, and this will be basically seed, takes the seed and returns a string. Okay, that's it. Do we want to do that? Ay, because now I'm thinking like, okay, we'll be repeating that. So let's also say seed, which will be number. And we're gonna give it index, which will be also a number. Okay. And we're gonna keep the index first. So the index will be basically a value that, you know, which run of that specific query definition is it? And this way we can specify, do we actually want to specify it? I've got an idea. Yeah. How do we generate iterators in JavaScript? That's a good question. Hey, Methodates. Methodate says, okay, now tuning in mentally. How's everything going today? Pretty good. Pretty good. Just finished testing some of the 202. And performance pretty much the same within, you know, like 1%, 2% difference. So I'm happy about that. And now actually I'm gonna use the whole schema defined for the blog for defining tests here, so we can just run a larger set of queries and just test various aspects, and just with an idea of rerunning it every time there's a new release of the database or something, and have some kind of idea of more of a real life scenario rather than random focused things. So just modifying how this works. So yeah, all is good. How are you doing? I know that I stayed very much on topic. So let's go to our Claude again and ask it about iterators, because this is all good. Delete. Let's just start a new query. Okay. How do I define generators / iterators in TypeScript? I need to be able to pass a value that then something else can keep calling in a loop until it's exhausted. Yeah, because JavaScript calls them generators or something. Function star for generating functions that implement the iterable. Okay, so we've got class range implements iterable. Oh, iterable class? What? Um, what the heck? And usage. That's a bit more than I expected. So the constructor to private start and number, okay, and we have symbol iterator. Okay, iterator, okay. I guess that's the special symbol so that there it's not as a name. And we just have this thing. And we call next. I'll return the next. That then returns values. Okay. Okay. That's a little bit more complex. Great. Now please define me an iterable that sucks if I need to define an iterable. Is there a simpler approach that doesn't involve creating some specialized classes? Just a function instead? Okay, that looks better. Yeah, now we have yield and everything. And keyword generator. Okay, that's a little bit better. I'm fine with that. So function creates sequence from here to here. Not explain. Stop. Seriously, I select something and improve or explain. That's interesting. Number for let this and that. Yield. Great, that's all I need. Okay. Cost sequence is this. So create sequence returns generator number. Okay. So I just ask for a generator. So let's say that I define it as a function that I give it the seed and it returns me a generator of strings. This isn't heavy. Function type notation must be parenthesized when used in a union type. Okay, that makes sense. And Mithridates says, awesome, now up to date. Everything's good over here. That's great to hear. And again, I start feeling like it's Friday while it's Wednesday. Ay, ay, ay. The streams are confusing me. Okay. And I actually can't wait for Friday because there'll be more Seabor. And I'm like hyped about Nim again, which is very surprising. But I guess it's because things are somewhat working. Okay. And did I lose internet? What's going on? No, it's good. Okay. Twitch is acting up a bit today. All right, so the query will just be either a string or something that returns the generator when we provide it with a seed. And this way we can just provide, this will be this could be a function that we provide with seed once, and it keeps returning data depending on that one seed that happened, and we don't need to keep repeating something over and over again. So that is great. And if that's the case, we can propagate it up and we'll have all those query definitions. Everywhere this thing goes, we can call those queries. Okay, so that's good. So now, now we need to start implementing it. So timing result, all that stuff is good. So in benchmark runner, we basically go over the queries. Okay, so we actually need to get the generator. So let's do const generator, or like query generator is this thing. So queries is, and then we're going to do benchmark dot, oh, because we have a bunch of queries. What the hell am I thinking? Oh, I just realized. So I guess I'll remove that little bit of text. So we can have multiple queries defined in a benchmark, and those queries right now I made it that when I do run query, which I have defined here, can actually run the additional things. Okay, and what is this? So run query, Surreal and query definition, and here, if it's a generator, I do extra stuff. Okay, so I don't do anything here. I just run it through here. Great. Okay, so I just need to require a little bit more work here. So we have this times, okay, for each query run, right? Okay, so that's good. So results, okay, I straight away just grab the query from inside the query, which is, if it's a string, do that. If not, do something else. Okay, so this is where we actually want to get the values properly, I believe. So we could do let queries is, I'm not gonna type it right now. If type of query is string, we just return that one string, right? So not if, because this is JavaScript, right? Type of query is string. So if it's string, then we're just gonna set queries to the query, right? Just that string, but as a list or array, so that we can still iterate in a for loop. Otherwise, we're gonna say we need to initialize the generator, so we need to get the generator, I think. We're gonna do this, and therefore we need to pass the seed. There we go. And the seed we just run it once here, and then we're gonna do for query query string of queries. Okay, and this is complaining now because can't find the name queries. Okay. Weird. Oh, because I can't have this one. Okay, now we're good. And all that stuff will go in here. So this is times number, this over the results. So let's redefine our times for all the way up here. Oh, wait. What the hell's going on? Times. Push the timer. Okay, we just return them. Okay, so that's good. We can safely define it down here before we get to the array. And therefore we have results. Bam, bam, bam. We iterate over the results and put them as that. Great. So that could be running in a loop, no problem. Okay. Okay. So query string, therefore we replace this with a query string. Run it, get results. Poof. What is this thing? Something's flying around. Okay. All right. This will allow me to basically run it all. And we used seed only once, which is great because all the values generated from that will be able to reuse it, reuse one variable, so it's not going to be extremely slow either. Okay, so we need to also be able to provide the seed. Okay. And now it's happy. So now this part is unhappy because we don't have the seed. So we need to provide it with seed. So how do we do that? So in here, when we run the benchmark, we already have the database defined and a benchmark. And I want to provide it with a seed number here. And what we're going to do is when we run over iterations, our let's just call it something like n seed. Okay, so that's the input. So let's seed is in seed times iteration. Okay, whatever iteration number we have, we just multiply it to get some random number. But at the same time, we don't want to be multiplying so much. If we have nested, we need to start doing some other stuff. Do we do something like bitwise operation or something? Because that makes sense. Right. Now I need to be able to generate seed numbers. I want to take a number and apply another number on top to always get the same result. Numbers. But be able to safely keep doing that indefinitely. Numbers won't overflow. I don't mind if they're all over. Example. Let seed is input number. So this will be mix input number, comma, iteration number. So after running it will be input number was 1, 2, 3, 4, 5. Iteration number was 10. Mix is, for example, right? Let's see what happens. Requirement for pseudorandom, blah, blah, blah. So there was some simple, whoa, okay, this is not simple. I remember seeing that at some point. Iteration number and returns a number. These begin to avoid overflow issues, blah, blah, blah. So we get prime numbers for mixing. Okay. Mixing algorithm. That's a lot to run just for that. Back to regular number. Max save integer. So we do some bit stuff here. Let's try that. Because why the hell not? We'll see what happens. If we're gonna get decent results. I have no idea what I'm doing. I'm just avoiding thinking right now. It's been a long day today. So let me just create new file utils.ts, and we're just gonna go like mix number to create a new number. Okay, I figured that out. Okay. So let's mix seeds. This way it's gonna be better, and we can just go over here, and our seed will be basically mix seeds. We're gonna take the end seed and iteration, and hopefully that's gonna do something not indecent. Okay, and I need to remember to export it. There we go. So this should let us get a mixed seed for the iteration. Okay. And then, so let's call it iteration seed. Okay. Continue connection, this and that connect. And the whole thing is that we'll be running all the queries here. So for each query, we also need to do something. So we're just gonna do let query seed is mix seed. We take that iteration seed and seed it with something else. So, now I need ID of this thing. For let I 0 and right. Oh yeah, we have additionally iteration setup queries. We're gonna get there, okay? We're gonna get there. Benchmark dot queries length. There we go. There we go. And this way we can just start here with const query is this, and this won't change either. Neither will this. Okay. This is convoluted. It loop within a loop within a loop. But we have the query seed. And we use this and I. And we can just plop the query seed here. There we go. Okay. That works. And if these are just static, we don't worry about it. Good. So I think we're good for now here. We're passing it along. So the next thing would be to just continue with the thing here. So run benchmark already takes the seed. Okay. Instead of calling it end seed, I'm just gonna call it seed. There we go. So what is calling run benchmark? I think we're running it inside our index. Okay. There we go, run benchmark. So we need to provide it with seed. And that means for each benchmark, we're basically defining seed. Const benchmark seed, mix seed. And again, we need ID for the benchmark. So I'm gonna go for bam, bam, bam. There we go. Benchmark seed will be basically I. All right. Although we won't be using I in here, we're gonna be using bench index. Okay. And we just don't have the initial seed. This will be the DB seed. Okay, good. So now here we iterate over plans. So let's do for let plan index. We go over the plans, we get our plan, and do const plan index and plan seed. It's just gonna be literally plan index. Okay, that's it. That's good. So we go over the plans. Then inside the plans, we go over benchmarks. That's it. Oh, because this other thing is going over the plans. Somewhere here, right? For all the plans. Of course. For let plan index. So this is what it really is. Okay. We do the plan, run plan, comma, plan index. There we go. And run plan takes the seed. And therefore here, these are not plan indexes. Where did plan.db's length? So this is not plan index, this is db index. There we go. And here we go, the db plan.benchmarks. What? Oh, yeah. And we've got this, and we're running it as db. Okay. db's, get the db from here. And db seed is gonna be mix seeds. Bam. db seed. Well, here, take db seed and put it here. Okay. And therefore we can pass the benchmark seed. Alrighty, this finally starts to look like something. Nuts. I wonder if it still runs. Because something's unhappy here. Oh, just those errors. Okay, so they don't matter. Okay. So if that's the case, can I run it? Let's say that I want to just run the stuff on Vision and Homelander only. And I'm just gonna run the Tombstones benchmark because that should go relatively quickly on those two. And let's see what happens if I'm actually able to run it, or is it gonna wait, run start. Errors. Cannot connect. Oh, I'm getting the error sometimes. Oh, and also I don't want to run it against all the possible databases. That would be a little bit too much. So let's go to databases, and we're gonna simply say, you know what? Use only this in memory and this in memory for now, so that it just runs fast when I try to run it. Oh, we're getting problems with connecting to Homelander. Don't we have it running on Homelander? Let's investigate. Homelander? Oh, I don't have all of them running. So we can stop this one. And I'm just gonna... You know what? Let's stop the stack. Let's start it over. There we go. We have it running. And let's do the same thing on Vision. Stop it all. And start them again. We've got all our 5 instances running. Great. That means I should be able to now run. Oh, there we go. So they keep going. Okay, over databases now. Okay, both of them finished. So that worked. Great. Okay, so that worked. That's good. So that means that we can simply move forward. So I'm gonna push those changes for now. So in benchmark, we wanted to only do this one, benchmark runner. We need to change, commit all that. And lock changed, of course. And those changes we are actually going to delete because we don't want that test going in. Okay, mixed one doesn't matter yet. Inside index, we need to push those changes because these actually matter. This one and this one. And this is just changing which we want to select. We want that part, our package.json, yes please, and utilities, yes please. So let's do support generating queries on the go based on seeds. Okay, there we go. Let's push it. Great. Okay, all right. So if we have that, now we can possibly start integrating the idea that there's benchmark setup queries and teardown, and then iteration setup queries and teardown. Okay, this way we can kind of start doing things. So let's just add one thing to the idea of the query. In here, we define a type query definition. So I want to also do export function. Get iterable. And we just give it the query definition. And this will be either a string or generator of strings, okay? It's gonna be either of those. So if it's a string, return this, otherwise return this, and we need to give it a seed. Okay, this way we can just quickly reuse it and not worry about it too much everywhere, because right now in our benchmark runner and run query, we have this specific thing. While we'll be doing a lot more for setting things up and doing other things. So this way, queries can be simply, wait, this shouldn't be capitalized, right? Get iterable. There we go. So get iterable from the query, and we provide it with a seed, and that should be it. Okay, good. So this simplifies things a little bit. We've got our queries, we do all the other bunch of stuff. So that's good. It's just our times went away somewhere. What? Oh, that's true. So let's just grab this and undo a bunch of stuff. And bam. Now we're good. Okay. So the thing is that when we start our benchmark, we want to initially run some kind of set of queries before the benchmark starts and after it ends. Okay. So when we have our run benchmark, okay, before we even define the results, or we worry about results, we need to, run setup queries. Benchmark setup queries. Okay. So let setup queries. Okay. Okay. So we have a list of them, right? For const query or benchmark queries. And this is again where we need to run with the iterator in there. So for let benchmark setup index is 0, benchmark sub index, blah, blah, benchmark sub queries length. Okay, and we have our query here. Our query seed, we just build it out of that. And here normally would be run query, right? But wait, run utility query. Gonna call it that way. And this way we'll actually have two variants, because we already have run query, and this one, besides just running queries, also knows the time, how long it got to execute, and all the other stuff. So we're gonna add a new variant of it, async function run utility. Okay, and it's gonna have all the same stuff here. Okay, the only thing is it doesn't return anything. Just bull if it succeeded or not. Okay. And because of that, we can actually mark it as runs a query which doesn't keep track of time nor return results. Okay. So we can copy this part because we just want the queries, right? And we want to iterate over them. Bam. And that's it. So we can just do promise void. Okay? Because we're not returning anything. We don't even care about the results. We just await it, and that's it. Okay. I think that's that for running utility queries. Great. Okay. So run utility query, and this will be the connection. Really, that's it? Surreal, which will be the connection. Oh, because we already have the connection established at that point. Oh, well, here we're doing it per iteration. Ay, ay, ay. We can still do that. Okay, let's not try to open up a new connection or anything. We'll simply say it, specify it, let is has been is benchmark setup. And we're just gonna say false because it hasn't been yet. Okay. All this stays the same. And when we start our first iteration, right? Running iteration. We create our new connection. And here we have iteration results. So here we're gonna say run the benchmark queries if not already done. So if not benchmark setup, we're just gonna say bam, run it all. Okay. And here we have connection as database. Okay. Good enough. So run those queries and then you specify that it has been set up. And then run the iteration set of queries if not already done. Iteration, just run the iteration setup. Okay. Queries. There's nothing to check for here. So query benchmark iteration setup queries. There we go. Bam. We do that part. And we can go on with our iteration, run the query from the benchmark. And after we've done that, we don't close the connection yet. We do iteration teardown queries. So yeah, it just replaced everything with iteration teardown. There we go. And the last one is run the benchmark teardown queries if this is the last iteration, right? There we go. I figured it's good enough. And then we close the connection and do all this bunch of stuff. Ooh, that really expanded to be something big. Okay? But no matter what kind of mess that is, it should be good enough. We just need to make sure that when we define our benchmarks now, that these default to this. Can I specify it here? Not in the type, right? Ay, ay, ay. Oh well. So let's go to our benchmarks. Okay. With our benchmark definition, namespace, and let's do benchmark setup queries, nothing. There we go. Teardown, nothing. Iteration setup and teardown, nothing. Okay. Because this one didn't need anything. This one doesn't need anything either. And that's good. And we can do the same with tombstones. Bam. And that's it. I already have the create queries, which in theory, go away. Let me just run those again, because I want to see if what we have now actually works. Okay. Okay, it looks like it works. So now when that finishes, I'll be able to basically say, you know what, instead of generating how many? 100 of the strings ahead of time, I could just create a generator function that does that 100 times, and that's it. So let's try that. Okay. So we had this help from Claude specifying how we can do those things roughly, right? Use those random. And we had this thing here. Okay, create sequence. There we go. So let's copy this thing. And this should return the generator. Bum, 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 bum. So generate create queries, right? Because I'm just gonna name it the same thing. Start, end, and the step. Okay. And we need to give it seed, which we'll happily ignore. Okay. So we've got that part. Or is it really that part? Because this, how do we create that? Queries is this. So this should be a function that returns the generator. Oh, where did all that come from? Let's do this, okay? And therefore, let me copy this. Oh, and kind of redo it a little bit. Here I'm ignoring the seed. Ignoring the seed as it's not necessary. Okay. And then we're gonna have, this is the list of queries, and that's not what we're doing, okay? So we go over the number of repetitions, right? So iterate and start queries push, which is gonna yield the value, okay? And okay, and here we're saying how many times to okay, these are names. What the heck? Oh, and we just get those numbers here. Huh. That's different. I guess it doesn't matter too much to have that specific name here. It's good enough. We're gonna just say yield this number. I mean this specific string. Okay? That's all we need. And we finish our loop. And in theory, that'll be everything. And this will be, of course, a generator for a string. Okay, so I can comment this one out. And I'll just do it this way. Is that possible? This is queries. How many queries? So we're just gonna put this one in here. And it's not assignable to type query definition. Oh, of course. Name is create and delete records. Okay. And then we got the query, which is this thing. I guess that's how you do it. Let's see if that's the works. Query create and delete records took this and that. Okay, good. I'm happy about that. So yeah, we reuse most of the code. We're good. So I'm just gonna take this part, plop it on top of here. And on Twitch, Dragonfleece is asking, what does the asterisk do in front of a function in TypeScript? So this marks it as a generator or some sort of thing that you can iterate over, I think. I think it just makes it return a generator so that we can use yield. So if you're gonna take this thing, run it, and it's gonna return the generator, you can then take that generator and therefore you can do like a for loop over it. So if I would say const generator, right, is, and I'm gonna run this thing. So whatever it does, it just iterates over something and yields some strings, okay? So now I got this as a generator. It's a type generator of strings. I can say for, I say let text of the generator, I can log it, okay? And I could run it. And this way I can make my own things to iterate over. Yeah, so, you know, you might think of, okay, I'm gonna make generate create queries, right? And why do I bother with this weird thing with weird yield and some generators, right? I'm just gonna return an array of strings, right? Yes, they are lazily evaluated. That's the thing. If initially I had a function, because I was running quickly, that just returned a list of strings, which means that at this point it generated, in my case, 100 strings. But if I would change that to 10,000, that would change, 10,000 strings, and just logging around that array of that many, it's pointless. And this is very useful not only for lazily generated. Imagine that you have some kind of API request here. So you could make iterate over something that basically takes stuff maybe from a queue or maybe from something else. And the moment this returns instead of yields, I believe, or just, goes out of here, I think it can just do normal return. It's gonna just say to the for loop like, oh, sorry, there's no more values, and it exits. So they're really nice. Or maybe you have something that you're more like, you know what, this for loop might actually not finish completely, so there would be no need to evaluate all the possible values ahead of time. So there's just a lot of stuff that could be done with generators. It's one of those features that when you realize like, oh wait, you know what, this is perfect use case for me and it's gonna save me a lot of headaches. Okie dokie, so we've got our stuff somewhat ready, I think. So that means that we can probably head on and start defining our proper benchmark. Okay? Because our benchmark runner and everything is in place. Now we can start getting to the mixed one. So I'm gonna straight up copy this thing for this benchmark and call it mixed one benchmark. Okay? Because one is for number one. Dragonfleece says it was added in ES 2015. Dang, I'm way out of the loop. Yeah, I must say I need to learn TypeScript myself, like from scratch, the way you're supposed to learn it, because there's just so much like magic with types. And sometimes I'm tired of fighting with the type system because I'm not fully understanding it. And generators, I use them in so many different languages And here they're called generators, and something like nym, for example, will be iterator, and something like C#, you have, I believe, you just define it, whatever, some enumerable, but it's just a bunch of weird stuff. Lots of languages have an equivalent of that. Okay, so mix1 benchmark, we'll call it mixed1. Namespace will be mixed1, just for sake of consistency. So we'll have our queries for setup, teardown, and iterations and whatnot. So the thing is that I don't want to run this thing in iterations. I want to run this thing once and just be done with it, okay? So I'm just gonna do constant iterations 1, okay? Do not repeat as this is single iteration benchmark, okay? I'm just gonna put that here so that I don't have wrong ideas at some point. So we need our benchmark setup, which we basically, hey, load all the schemas, load the schema into the database, and that's it, okay? So yeah, we could do that. I'm just wondering how to do it properly in JavaScript, huh? So let's define a query. So it'll be const setup query, which will be query definition, okay? So name will be setup, and our query will be literally load the query from a file. That won't help me much. I hope AI will be smart enough for that, but not really. So I know that this will be the setup query. We're just gonna have only one, so we're good with that. And of course, we need to define it ahead of time. So now this thing, how do I load it? Can I just do import next one schema, schema from assert type? I don't think that works that way. So we're gonna simply load the file manually, okay? But I don't want to hold this whole file here, so we're just gonna use our fancy generator function. This will be load schema as query or a string, yeah. It needs the string, the seed as number that we don't use, and it will be a generator of a string. So in theory, we could just do yield the string, right? So bond dot, how the hell were file operations in bond? I keep forgetting. So what do we have that? Directories, incremental, writing files, reading files, okay? So we can just say const foo is boo blah blah blah. Okay, that's good enough for me. file is gonna be mixed one schema SurrealQL. Okay, so this will be the query. Okay, and just yield the query, and that should already be a string. No, that's a bun file. Size, type, and text contents as a string. Great. I don't care about stream. It's just gonna be text. Dot text. Do I need to await it? I need to await it. Oh, how do you make generators async? Oh no. Hmm. Hey, this is not complaining when I call await. What? Can I define? Can I make my TypeScript generator async? How can it be used? I have this so far. Please correct it accordingly. Okay. So let's say I have this thing. Needs to be awaited. Okay, let's give it that hint. And then we're just gonna have for let query of load schema as string. Yeah. And do stuff. Okay. Just something simple like that. I'll see what happens. So, but there are a few adjustments needed to make your TypeScript generator async and use it correctly. So it needs to be async, and it's an async generator. Okay. That complicates things a bit. Process queries. Blah, blah. For await of something. I was reading about it somewhere. Something recently, I think, introduced support for that. I don't know what. Maybe browsers actually, which will be cool. Okay, but that complicates things. But yeah, I would like them to be all async generators. Why not? Why the hell not? Async generator. There you go. And now it's unhappy because this needs to be async. Now it's happy. And now this will be unhappy because I'll say the query is this thing. And this isn't happy because this is supposed to be generator, not async generator. So we're going here, we're gonna say that this needs to be an async generator. And that will make other stuff unhappy, like get iterable. That converts it into async generator, so that's happy now. This is happy, and there will be many other things that are unhappy, like this one here. This needs to be async. Okay. Even though we're not using anything async there, it just needs to be turned into something async, so that one's fine. And that means our benchmark runner is really unhappy now. The whole thing is async, so that's good. What matters here is that we actually need to look into our utility query, because it'll be for async. Oh, for await. Ooh. Okay, great. For await this, so we're actually awaiting the next query and whatnot, so that's good. For await, great, and that might be actually all that we needed to change. And Yeah, that's it. I'm not complaining for sure. Okay, we're learning about generators in TypeScript or possible JavaScript, so that's great. Okay, so why is it still complaining? Can we find gen create queries? Oh, because this is the old one, right? We have setup query, which is here, which means that we just load that file once. When we need it, it's valid to be used up, and then it gets garbage collected. Great. So that's good. And I needed to make it a generator because I don't want to overcomplicate more of this stuff. This should be good enough. This is simple, right? Yeah. At the end of the day, it's copy paste and it works. For the teardown queries, I guess I should care about that, right? Yeah. So let's make another one, which will be const tear or cleanup teardown query, so that we can have the same names everywhere, right? So in this case, I'm just gonna do remove all those tables. Ay, ay, ay. So we remove and okay, let's see what we need to remove. Which queries? Remove. Remove access. Wait, I need to check the docs. How the hell did remove work? So we have create. What about remove? We have remove database, user, access, event, field. What if the namespace... Remove namespace. What happens if I just remove namespace? It's just bam, deletes all the data? To more resources such as databases, tables, indexes, events, and more. Similar to SQL job. Okay, let's test that. That would be very awesome. So let's say, sure, Surreal1 and memory. There we go. So we are in what namespace are we in? Does not say. That's interesting. Oh, connection failed. Really? Surreal2. Oh, because it's trying to connect to Java, right? And I might not be running them on Java right now. So let's make sure that we have them running. Let's go to Java. Serial benchmark. See, they're all down. So let's stop them and restart them. Come on, this one's really slow, as you can see. And come on. I could have grabbed water in this time. Okay, we got them running. So let's connect to like whatever, Surreal 2.0 and memory. Okay, there we go. So what I'm gonna do is select the namespace. Okay, new namespace, which will be Wallala. Okay. In here, we're gonna create a database, Wallala. And because of that, I'm just gonna create all of it, right? Grab our code. This one. We actually don't need the other one anymore. I mean, we need it. So, okay. This thing, select everything. Paste it here and see what happens. Run. And we want all of them. And they all passed, okay? So that's great. We go to designer. Bam, we've got our whole schema. So that's good. that's the case, that's good. Let's just generate a bunch of, I don't know, topics. Okay. Can I see like Explorer topic created? Oh, I need to get a template of it. It'll be T, so somewhere towards the end. Series topic. Okay. So go name, description, and slug. Okay. So create topic. And let's say that I create, 300,000 of them. Okay. I'm gonna create 300,000 topics. Set, and we're gonna say name is a topic, and then we're gonna say description is optional. It's not optional. Whatever. And wait, I actually have to have this as equals here because it's a set clause. What else? Slug. Oh, slug needs to be unique. Oh, I don't have an index here for that. That's interesting. I'm just gonna assume it's needs to be unique. So something dash topic dash I think I can just do plus. I don't remember. And we just say convert to string. And what we'll be converting is random. What the hell was that? I keep forgetting everything. That's what happens when you don't use a database like every day or something. But at the same time, there's just so much and it's so easy to search something. Random floating point. Random GUID. Random string. There we go. Random string. What the heck? Sure. Random string, and we're just gonna say 10 characters. Okay, there we go. And this should let us generate 300,000 topics. Let's just make 3 at first. Run. Found whatever for field description. The field must conform to value length is larger than test. Okay, happy now? Well, none for field last update ID. But expected a UUID. Oh, right, because that's our another requirement. Last update ID is do we have like a UID or something? There we go. There we go. Happy now? Field must conform to value length and value is slug. So I guess this is not a slug. So random. Oh, this needs to be a number integer, right? Int. See how many rules do we have that the database keeps checking? So this is what's gonna actually start changing things. Like, oh wow, because we had double dash because this is a negative integer. Seriously. From to, okay, from 0 to big. Don't we have like a better ID? Sequential one. There's ULID. But that isn't the greatest. But let's try to do... Gosh, this is taking long. ULID, okay. And we just take this. And this will be now string functions. Lowercase. There we go. But this won't work on 1.5 suddenly. Oh no. Oh wow. Actually, the whole thing won't work on 1.5. Holy macaroni. So what we're making now is actually a benchmark just for 2.0. Because we would need to have two separate benchmarks with using two different features for everything. Okay, I see. We're gonna switch our gears a little bit. But we've got lowercase. Okay. So let's just assume that this is all right, okay? We'll run the query. Did you maybe mean this? D. Yes, you are correct. There we go. So we generated 3 values. That worked. So let's do 300,000. And I just need to say return none, because it will try to return all 300,000 records for us, which is not good. Let's just wait for a few seconds. It's loading in memory. Hopefully this is not too much or anything. Okay, we generated. So we go to Explore, go to Topic, refresh, and then we've got 12,001 page of random data, okay? So that's not bad. That isn't bad. I mean, it's all in memory, but nonetheless. So what I want to know is, what if I'm gonna run remove? I mean, I'm gonna keep this thing for now, okay? Remove namespace. And do I need to specify which one? Wait, statements. Remove namespace and a name. So remove namespace, Wallala. Run. Okay, return none. If I go to designer, there's nothing. If I will go to Explorer, there are no tables, right? There's no data. I removed it, just bam. Okay, I think we found the best way to clean up. Just remove the namespace afterwards, and therefore we have no trace of any databases, nothing. Okay, I am liking that option. So that means that remove namespace, and I'm just gonna do const namespace is mixed one, okay? This way we can just specify it here and we can use it here. Okay, there we go. Just like that. That's our cleanup query. Teardown query. Okay, not bad, not bad. Nothing for iteration because we have just one iteration, so that's good. And then we will need to have our actual normal queries. And this is where fun begins. Because this is our setup query, number 1. So let's make it schema query. Schema setup query. That will be our first one that we're going to run. But then we basically need to define, we will need to define a bunch of queries that add data to our database so that we can start testing and querying. But now that I realize that we can't test it, use this against, 1.5 versus 2.02, we're gonna just keep this like that for now, okay? We're gonna leave it because this is a good bunch of work that we actually figured out. We prepped a lot. But we're gonna just make a new little thing here, right? So new test, and let's start thinking what we would want to test. If somebody has an idea what they want to actually see when benchmarked or tested something specific, just let me know. I'll be very happy to do so. For now, I'm just gonna do select, and we're gonna say simple or something like that, okay? And yeah, sure, select simple .ts, and I can actually probably copy all of this code because we're gonna reuse a bunch of that. Okay, namespace will be select simple. Okay, we're gonna say that we're gonna run it maybe 100 iterations for now, right? And this test will be basically gonna create some data, run a bunch of various queries, 100 times each, and see how they fare. Okay, just like that. Some simple queries with simple where clauses. Something that doesn't jump around any other tables. Just everything within one table. We'll see how the evaluation works. Okay. Select simple. Then we're gonna have basically the setup query and consts data gen query. Okay. So will be created here, and then we're gonna have teardown, which just tears down the whole namespace. We probably won't do load schema as a string, but gosh, these are actually becoming kind of useful. And this will be our not mix what benchmark. It will be select simple benchmark, and we'll just call it this way. So our first will be schema setup query, and next will be data gen query, and this will be teardown. And per iteration, we're not doing any additional setup. Okay, and we'll have a list of our queries. Iterations will be iterations. There we go. Okay, so already, because we were able to copy and paste, our previous efforts weren't wasted. So now let's just think about the actual query. Okay. I'm gonna straight up new file, select, let's just do data / select underscore simple underscore schema. Okay. There we go. So in our select simple, it will be basically data /. Okay. And now we'll just have it loaded from files so we can just edit it easily. So the whole idea here is that we have one table that's already defined so that, when we generate our data, we don't have any problems. And we'll find a way to just generate the data and just, get it going. Okay. So we can borrow a little bit from this one. So we'll have define table. And we'll just call it table. What do we call it? What do we want to query? Let's say comments. Okay, because comments kind of sound like something that could have various of, a lot of various data. So we're gonna have comments and type normal. Because we want to actually make it work with both 1.5 and not 1.5. So we're gonna need to limit the number of things that we have available, okay? So if comment, what? Besides the ID, what will we have? Define field. And we're gonna call it author on table comments, and that will be just type string, okay? Just some kind of author. Or can we just do record? Okay. Record of type user. And the type doesn't need to exist as far as I remember. So next will be what? Command will be define field content will be comments. Wait, yeah, that's gonna be just a string. And then we're gonna have additional one. What else could be there? Maybe when it was created. Define field created at. Okay. We don't worry about updated at. But maybe, sure, updated at and define field deleted at. And that will be also another date time. This way we can run queries where maybe we're checking if it's deleted or not. And what else? Yeah, define field likes, how many, and define field response to another comment. Okay, so we can interlink things. And let's do approved and type boolean. I don't remember if it was supposed to be boolean or not. Let's just see. We're gonna create namespace wall again. And sure. Can I do that? Problem. Boolean. I think it just needs to be bool. There we go. Okay, that's good. What if I'm going to go to something like Surreal1 in memory? Namespace wall database wall. Okay. I run the same query. Okay, I think it's happy. Designer, we've got comments in both databases. Great. Okay. So now the whole idea is to also have some kind of index here and there. Okay. What kind of index could make sense here? I guess if on deleted at, which needs to be an option of date time, to be honest. Okay. Updated at. We're gonna leave it as necessary because it will be the same as created. And I'm not worrying about default or not. We're just gonna create whole records straight. That shouldn't impact any performance on querying it. This one will be 0 by default, so that's good. And this should be also an option. Okay. All right. So now let's just take a peek on how to define some indexes. So yeah, define index unique. Wait, what do we do? index by author, and table comments, column author. Okay, no need for unique or anything. Deleted. Add index. Whatever. Index by deleted at. Okay. And this should be good enough, right? As for something likes or what, we can't check, as far as I know, we can't just do it if it's larger or smaller, which is big limitation of the indexes right now. But I think this should be good enough, okay? Let's see. I'm just gonna do remove table comment. Oh, I'm naming the comments. Ew. Okay, so let's change comments to comment because that's a little bit more the way it's supposed to be. And Taras says hello. Hello to you too. How are you doing? What brings you here so late? Okay, so let's see. Can we run this query? No. An identifier. Expand kind of name. 9. Oh, of course, because I never fixed this thing. There we go. Beautiful. So we need to fix it here as well. And let's just double make sure that it also works in here. Taras is saying, you did such a great job with Seaboard last time. I'm so proud of you. My daughter had football practice. Football. Oh, as in American football. Or the soccer practice. Which one is it? Because double football doesn't change anything. Oh, I need to show you, Taras, something. I actually need to show you something. I absolutely have to. I click here. And I'm gonna go here. Look at this, Taras. General tests. Test Seaboard reader, writer, arrays, booleans, bytes, integers for decoder, everything for encoder, overall encoding back and forth, and just those. And now look at this. Run task, run tests. Ignore the warnings, it's from external library. But yeah, we actually got lots of tests. Lots of tiny ones. But yeah, they keep going. Taras is saying, you're now more advanced than most of libraries writers. Yeah, so we've got tests. And these are not comprehensive because what? We've got like tests for the decoder array, right? Just I have some helpers for encoding and check if it's that. The most important are actually for encoder. Like for Boolean, I'm checking that if it's true byte. Or for bytes, I'm actually running some binary tests. For strings, the same thing. I'm just encoding binary and checking. Objects is the most comprehensive because this is an example what you can do. Take this whole object with text and numbers and lists of strings and within that another object, and I have nicely even commented out a representation of that, and yeah, so I did a little bit of that. Taras says, when you say football in the US, it usually means American football. So football could be claimed by soccer. Okay. I guess I'm not circling around those crowds that do anything around sports, to be honest. I'm most excited by code. Okay, so enough of the NIM stuff, because that's not the focus on this stream. Okay, I'm just really excited about that, and I can't wait for Friday because we'll be implementing tags. And after that, we'll be able to actually start trying it out. So I was about to put all this in here. Let's just do remove table comments. Yep. And let's define it here. Okay. It looks like it accepted it. Good. So we've got proper thing, and it should have indexes, right? Indexes. There we go. Good. So this should be our schema definition. So now we have to specify how to actually make it. So we need to generate a bunch of data, and this is where our random thing will start working. And by the way, Taras, how's your crazy SQL adventures? Okay, so load schema from a string. From a file it's gonna work, and now we have data generation query definition. So so with this thing, we can probably just make it as a function that looks similar to this one, but instead of returning a bunch of stuff, it will be still returning strings, but instead of us just returning one or doing something in a simple loop, we'll be able to actually loop through it a little bit more. So that's fun. So we need to generate a lot of comments, right? So we can probably run over several iterations of that to some extent. Let me think. Because so the IDs will be random and we can't get them back. So we will need to specify our own IDs for the sake of testing here. Because we have several things here. You know, who is the author, so we can just generate random number of authors initially and just keep applying them, right? We're gonna maybe generate 2,000 authors just to have them to just take stuff from the pool. Then we're gonna content, just random words, created at and updated at. That's gonna be just random dates, so not a problem. And then we're gonna do likes, that's the number, and response to. So that's the more interesting one. So I would like the response to be targeting only the ones, the comments that were approved. So that, or maybe not, maybe I'm just gonna make it random. So I'm gonna keep a list of IDs that we generated and randomly just say that this is a response to something. And then we're gonna just specify approved randomly, and we'll be able to run a query that shows us, show me all the comments that are responses to something that, for example, wasn't approved yet, or it's a response to something that was created before it was supposed to. Things of that sort, right? So yeah, that could be interesting. And Mithridate says, I have a friend who was absolutely into no sports, but one day decided that American football was just like chess. Lots of thinking and analysis before they ever move. And that became his only sport. They are on pause. Oh, Taras says that the plans for, SQL stuff are on pause. I'm looking for a new job as my current one might not continue employing me beyond end of the year. Ay, ay, ay. And my salary was reduced. I'm sorry to hear that. I have found part-time job in another startup, but it pays poorly. But at least it's something, so I guess I now have 2 jobs. Okay, and Tess says, Mithridates, does your friend play or watches American soccer? I guess soccer is lots of planning too, right? I know that there's lots into those sports, so I understand. I don't know. I just don't like the concept of following all the things that are happening. I kind of like that with technology. And if I would watch any sport, that would be snooker. That's actually one sport that I enjoy watching. But I usually just don't watch it because I don't have TV. And I'm not following scores and stuff. And okay, so we've got a part-time job at something else. Okay, so just in case you have something to fall back to. So that's awesome. Tara says snooker is cool. Oh, you're like the first person ever that knows what snooker is. That's awesome. Cool. Alrighty. And Tara's asking, have you tried playing snooker in real life? Yes, I did at the real 12-foot snooker table. It's horribly difficult. I absolutely suck at billiards or pool, and here in the US, I believe. So that was like extra hard, but I enjoyed it. Played a few times with my father. And Method says, not sure, going to have to check. Haven't talked to him in a while. One of those friends that you contact once every few years, and it's like no time has gone by. Nice. And Tara says, I think my hands don't have enough stamina for a full match. Oh yeah. It's few hours in my personal experience if you want to actually play it and count points and finish, because the more players suck, the longer you go, because you just have endless repeat of, yeah, it's just. And Tess says, I play regular 8-ball and pool with a giant white balls. Nice. I haven't played pool since I came to the US, yeah. I haven't been in any place of that sort. I used to live in a, big city back in Poland, so I had everything available, and now it's like I'm in the middle of nowhere. So yeah. And I'm not a person that goes to bars or anything. Okie dokie. So what the hell was I doing? Generating stuff. So let's get to generating stuff, okay? So let's say const, and let's say that this will be users count, and let's say we want 2,000 users, okay? Well, maybe not 2,000 because authors were doing. Let's say we have only 200 users, okay? 500, okay? I'm sure there'll be some repeats. Gonna make it like 50,000 comments or something, so we have large set of data, or maybe 100,000 comments and 1,000 users, okay? So it'll be on average 100 comments per user, okay? So now we'll be generate the users. So the users won't be existing anywhere. We are going to only. Okay, all right. I'm gonna actually generate those users. Define. What is it? Table user, and it will be just a name and email. Don't want any created ad or anything. Or although I'm gonna do that and maybe what else is there for user? Is admin. Okay. There we go. And define index. So be unique email. Unique. Okay. Oh no, that means I need to have unique emails. Oh no. How the hell do I ensure that? We'll figure it out. Okay, we'll keep track of emails. Okay, so at least we're gonna have the user and we're gonna have the email. So I mean the comment, and that will be good enough. So let's just make sure we have this here and we have this in this database as well. Okay, great. And we don't need anything else. And oh, this not even shows that this is through the field author. We have a link between them. Great. Lovely. And Tess says billiards was my favorite thing to do during college. All right. What the hell was I doing when I was going to college? Playing Minecraft. That was my thing. Endless hours of Minecraft. And who knows what else. So users. So we need to basically figure out that we want to const user IDs. Okay. And we're just gonna have an array of strings. And then we're gonna also have const user emails. Okay. It's gonna slow down, although not too much. We have only 1,000 users, because when we're generating users, we'll be able to just check, is this thing within there or whatever, just to avoid duplicates. Okay. So how are we going to do that? So we need to basically generate a string. So let's do for bam, 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 however many users we need to specify, right? We're gonna simply say, yeah, let's just get all the data first. So name, const name is, and we need to start figuring out, oh, an ID as well. Yeah, we're gonna get there. So let's take a peek at our thing to generate it, right? And Tess says, Minecraft is cool. I did it in my first job. On the second, we have amateur Dota team. Ha, nice. I actually didn't have any luck with ever at any job to find people who would play games. I don't know why. Even when I played, even when I worked at the game development studio, it's not like we all jumped on and played games. At one job, there was one guy that in our room, our team's room, because each team was, like 10 people max, with their scrum master right in the same room. Each team has their dedicated room or whatever. One guy had 240 hertz refresh rate gigantic monitor on his desk, and every day at specific time he spent 1 hour playing Counter-Strike, just randomly at work. And yeah, that was fun. That says, maybe in game dev you worked so much you didn't have time to play. It wasn't too bad, to be honest. It wasn't too bad. There are a few days where we had to crunch, but other than that, it wasn't too bad. It was MMORPG, so it just continued and continued. Yeah. So what was it doing? Checking the not random.js chance. There we go. So we can create a thing with seed, right? You can also instantiate your own chance of instance of chance with a known seed. This is useful for creating repeatable results. There we go. So we're gonna create just chance this. Great. So let's actually do it straight away here. So this will be, first of all, we're gonna call it whatever, generate users. Okay, and this will be the seed, and we're gonna have constant chance is bam, and we need to import it, right? Wait a moment. Please tell me it works as it's supposed to. Import chance from chance. Oh no! What the heck? We installed it, right? Bon install. Yeah. What the heck? Package. Chance. Please don't tell me it's only through required, because that would be ridiculous. What the hell? Script. What? I am getting confused. Taz is asking, which games have you worked on? It's Edengrad. It was, horrible game, to be honest. Absolutely horrible game. I don't know why it was being created in the first place. Are in the credits. I know I made the credits screen, but I don't know if they removed me after I left. By the way, I have showed stacks for my second startup, and they said I'm hired. That's awesome. That's very awesome. It's good to have practice getting, interviewed and hired, right? Const chance. Is it really that? Convert it to an import. And import doesn't work. Cannot find declaration. Has any type. I guess that's the problem. It's gonna be any for everything. What was it? Was it something like where is it? Packet JSON. Types chance. Does it exist? It might exist. No way. If that actually works, I will be very, very, very happy. Okay. Works. OMG. Me excited. So we've got chance. Great. So that means that we can start generating stuff. So name is chance.name. And partial chance. Just generate a name, please. Email. Generate an email. And the thing is that I want constant or like function next email. Okay. So it'll be while we don't want while true. Let iterate, tries left is 500. Okay. While tries left is larger than 0, we're gonna say this is the email. If user emails includes email, yes, push it and return email. Otherwise this, and throw error, failed to generate unique email. There we go. That's exactly what I wanted. This way we can just get, you know, all the emails in place, sorted out. Great. So email will be simply next email. There we go. That says YouTube suggesting me a video if Boeing made a Death Star. Such a must watch. Yep, that's a good one. Oh, not sure if they will be able to complete something that large. So what next? So we've got email. We need now the const created at is chance. Do we have like date? Okay, so that just converted to an actual date. Yeah. To ISO string. Sure, good enough. Then we've got is admin, which would be chance bool, but can I say it more like likelihood number? Yes, there we go. Likelihood, and I presume likelihood, what is the bool? Likelihood 30. Success returning 50%, so it's 50. Optional specified likelihood percent. Okay, great. So it's in this. Let's say 2% will be admins, okay? And okay, so we've got all data for the user. Yeah, so we just create this thing. Whoa. So we're just gonna go straight up create one by one. I don't care about performance here. Create user. Oh, we need ID, right? Const ID is chance dot UUID. No. What do we have here that could be done like an ID? Use this an ID thing, mobile, web. URL, location, time, finance, helpers. GUID. Version 5. Wild. But I'll be happy with that, okay? I'll be fine with that. Where was it even? All the way at the bottom. Hash hidden and normal ratio RPG unique weighted. Okay, we'll just say GUID, okay? Oh, okay. GUID, okay? So this will be literally user. Or we don't even need to do that. Oh no, we have to do that. User, bam, bam, bam. Okay, and we just do user IDs push. Here, email will be pushed itself as well. Okay, good. Great. And now we can say create user, which will be the ID. And now we can say set name, email, created ad. And for created at, we can, I believe, put D in front of it. Oh no, because this is just for the stuff. So, okay, now we have a challenge. We actually need to go through Surreal documentation and know which stuff was pre 2.0 and after 2.0. And something tells me this is going to be a challenge. So if I'm going to go to something like data model, Okay. We should have a date time. Okay, and date times. How do you create one? That says there is a small update on SQL project. I will do it closed source and will try to find some investment. If not successful, I will open source it. Go for it. Sounds interesting. Maybe somebody will actually want it. Sounds crazy, but I mean, if you would be able to pull it off, that would be like, wow. And I'm sure some companies would want it. I just don't know that I wouldn't have enough perseverance to actually complete that. I know that after benchmarking, I'll be making a set of live streams on making a specific product that uses SurrealDB as an actual backend, but it will be streaming development of every step of it, which is developing the backend for it, developing the front end for it, and everything. So it's going to be a long series. And it's going to be, you know, a public website for people to use. Okay, so what do we do now? So I can create dates that way, but I can also create it that way. Okay, and that's how we're gonna do it. Because I think this is gonna work. Because the thing is with those D's in front of it, I don't know if they were, you know, as of 2.0, previous or cast using datetime is required instead. So I just don't know if this is pre 2.0 or not. So we're gonna use this one. Just to be sure. I mean, I could just try it, but I don't feel like it. And is admin will be either true or false. Okay. All right. So that should generate 2,000 users. In theory. Okay. I just need to add this at the end, and yeah. So in theory, this is 1,000 users created. And after the last one, we just finish, and that's it, right? The thing is that this generates the users. So no, that means that. Okay, so let's not do it. Let's just do it, generate data here, okay? And when we generate users, we do that. So at this point, we're just gonna say generate users. Okay. And therefore, we're just gonna say here, after that will be simply generate comments, and we're just gonna go over that and see how that goes. And I will actually probably make it so that it leaves it in a database so that we can take a look at it. Method says they both work before 2.0, but 1.0 used to convert them to date times without telling you. Yeah, if the format matched. Difference is that D is an instruction to the parser, while datetime is a cast. That's why you want to use -DEC for decimals instead of decimal cast, because the number might not fit. Okay, I see. That's very interesting. It's good to know. For example, decimal some big number will try to make some big number first as an int, but if it's not too big for an integer, then there's nothing to cast into a decimal. Yep, that makes sense. Okay, but with datetime, it's as a string first, so we should be fine. And it's supposed to work, so yeah, let's just do D, and there we go, datetime. Looks nicer. Few less characters to send to the... although D... Huh. I guess JavaScript figures out how to actually send it. Oh, no, because this is all sent as a string. Okay, never mind. I'm just losing it. Okay, so we've got that. Now we just need to generate the comments. So with comments, we need to keep track of IDs as parents. Okay, so let's do let, const comments count will be 100,000. Okay, and then we're gonna have let's call it root comment IDs, which will be just a list of those. And basically, randomly, when we some of those comments that we generated will basically add to that box to be able to be, a something. Okay. So here we'll have author content, created, add, updated, and deleted, likes, response to, approved, indexed by author, or deleted. Okay, so this is gonna be a little bit simpler, I think. So let's do 4. Bam. It's gonna be a lot of iterations. So ID will be comment, and we again just generate some GUID, and I'm generating them solely so that because here I don't have access to actual things returned as a response, so I need to predefine them ahead of time. So that will be the ID. Then we're gonna have a constant author, which will be the... Oh, Chance doesn't have something like pick. It must have. Miscellaneous utilities. Pick. Pick is now deprecated in favor of pick 1 and pick set. Oh, okay. That's fun. I like pick set and pick 1. So we've got pick 1. Give an array, pick a random element, and return it. There we go. So author will be Chance, pick 1. There we go. Content. Ooh, a paragraph. We can generate a paragraph? No way. Paragraph. Return a random paragraph generated from sentences populated by semi-pronounceable random nonsense words. Awesome. Great. I love that. So much fun. I don't know why I wrote several mini libraries like that for myself that allow me to generate this and that, and I don't know why I enjoyed it so much. Random generation that turns into something fun is, for me, way more fun than playing with AIs. I don't know why. Okay, so we got content, created that. So it'll be just some random date. Updated at... It will be a random date so that we can have them all over. Deleted at will be chance.boolean with likelihood of maybe 3%. Okay, 3%, and basically if it's true, we just set a date. Otherwise, we set it to no. Okay, something like that, just to decide that. And then we're gonna have what number of likes will be integer from 0 to 100. Let's say to 500. There we go. And then response to chance bool. Okay, so this is the thing that sometimes we want things to be responses to. Sometimes we... Oh, yeah. So again, we need to say that maybe... Let's say that 75% of comments will be responses, 25% will be original content, okay? Or responses are... Yeah, sure, that's good enough, okay? So we've got that. So if it's a response, just pick one of the root comment IDs, okay? Otherwise, don't put anything, okay? And then at the end, we have the approved, which will be likelihood maybe 50%. Some of them are, some of them are not, and that's it. And we will actually add an index on that. Define index, index approved. And I'm just going to have them as loose indexes, and that's it. I don't know, because, I mean, those two make sense to be in one index, right? But other stuff, I don't know. I'm just gonna make it dumb, right? This is a simple case. All right. So got approved, and that should be it. So now I want to, now I generated the thing, okay. So chance pick one. Oh, what does it return? There's nothing to pick. Oops, pick one. I don't know. So let's just make that chance of this and root command IDs, yeah, so that we actually have something to pick from. Only then actually try it, okay? So that's good. And so basically what we're gonna do is root command IDs push here. So let's make it also random, okay? So we're gonna make it chance Boolean likelihood maybe 5% that something is going to be able to be commented on. So likelihood 5%. So if this, right? We're gonna make it into something that is actually commentable on. So that's good. And then we also need to wait, because we have root command IDs. Then we need to add it something else. That was the ID. Then we have author, content created, deleted ad, likes, and response to. I don't think so. Approved? No. Okay, that's it. So basically, allow only some comments to have a response. Okay. And now we can actually define it. So create this set author, content, created ad, updated ad, and deleted ad. So deleted ad. If it's null, we'll just specify it to be null. Okay, sure. Otherwise, we just create it as a date. What? I can nest those? What? I did not expect it to be nestable, but sure, why not? I never actually got to the point where I'm nesting the literals like that. Huh. Go figure. Maybe it's gonna work. No, in JavaScript it's gonna work. People usually want those crazy things. Likes, so that'll be a number, response to, and so again, is it null? If yes, and this won't be none. This null, it will be actually none because an optional. Okay, and response to. There we go. No, the syntax highlighting isn't right here. Or is it? Let's just do it this way. Response to, which will be this plus. Wait a minute, what the hell's going on? Response to. What's this? Okay. And instead of doing that, I can just, this is JavaScript, right? Okay, that's a little bit better. I'm gonna do the same thing here. Plus this, and what's that? Okay. Hopefully that's gonna be good enough. So we've got that part. And that's it. That's to create the user, right? Oh, geez, we'll be sending 100,000 of those. This will be a little bit slow. Just a little bit, okay? Okay. Cool. So, what we yield 100,000 of those, and that should be it, right? We generated data, and we'll be able to run the queries. Okay. Cool. Gosh, I want to just generate it to a file and be able to run it. Oh dear. I want to try that. Really, really, really bad. Yeah, let's do that. Let's create a file with a lot of queries. So this is a select simple. And I can just this will be data gen query, right? Good. And this will be generate data. That's what I called it. Yeah, generate data. There we go. Okay, this is actually not that much code, so that's good. So let's say async function save gen data query to file. Ha. Seed number. Sure. So we're just gonna do that, and yeah, I mean, this will generate various different things depending on the instances, but yeah, we'll need to change a few things in how we're generating that, because per database we need to start from scratch. Per specific benchmark we need to start from scratch, because sometimes they might run in different order. So yeah, okay, that makes sense. So we're gonna fix that soon. For now, let's just do constant query bound file blah blah. Select gen data, right? So this will be that, and then we can simply start writing. So generate data. Oh, so let's do for await query string of generated data, and we provide it with a seed. Write a query, and that's it. Is it that simple? There's no way. Does not exist on bun file. Bun right. Okay. And this is gonna be query file. And let's just rename that. There we go. So possibly I can just run that part. If that's the case, I am really happy. So export. Okay. Oh, where's my index? So I'm doing just straight up everything. And please, please, please give me what is it? This thing. Wait. Bam. 0. Okay. Just need to import it. I want to see what happens. Bond run. What kind of wait? Bond start. Okay, can't find variable. Gen create queries. There we go. So where is it? Here. Oh, of course, because this should not be here yet. Gen create queries. What? Oh, it's writing now. Okay. Oh, this is gonna take a while. Still writing. I'll be right back. I'm gonna grab some water. All right, I'm back. And this thing is still hanging. Oh, it just finished. And do we have a file? Where did it write to? Not you. Not you. This one. Where do I save it to? Data, select simple gen, data. Why am I not seeing it? It might not have written anything. So it said benchmarks. 1 kilobyte. What? It overrides every time I press, call write. Oh, and it indents everything so much. Okay, so at least we know that we have some things that we need to correct. First of all, we 100% don't need to indent so much. So you go away, you panel go away, you panel go away. It's just too much. Okay, you can see me. Yes, you can see me. Wow, YouTube has such delay. Okay. So in that case, we need to straight up do this. And that. And actually that. Okay. There we go. And I'm also gonna do return null. All right. Because that's something that we don't want to basically wait for the database to keep returning all the created objects every time or whatever. We just don't want anything in response. It's gonna speed things up a little bit, just a tad bit, but still, it's always something. So we need to also give the user the same treatment. It's gonna be return null. Okay, there we go. So that part is good. Now I just need to figure out how to write to it without overriding. Font file, reading files, writing files. It's multi-tool for writing. First argument is the destination, which can have an following type: string and path, URL, and bound file. Second argument is data to be written: string, blob, array, type, response. All possible permutations handle using the fastest available system calls on the current platform. There we go. Look at that. Nice. To write string to disk, great. To copy, to write by array, to write incremental writing with file sync. Oh, that's what it was. So we got file. Oh, we get a writer, and then we do. Huh? All right. Okay, so that's the only change. So we've got our query file, const query writer, and we just wait, do query file writer. Yeah. What does it take? High watermark, number, does not matter. And now I will be able to write. Wait. Where was it? Writer, right. Okay. Writer, right. And we've got our query string. Beautiful. Okay. This is gonna be so much better. Now we're actually gonna write it properly. And that took a long time. But I really want it, to be honest. Okay, so let's do the same thing again. So in data, we're gonna remove this one. And I'm just gonna run it again. Okay. I'm gonna run it again on start. So it starts to write our file straight away. Okay. That's good. Now in the meantime, I can go to our index, and basically this is where in the background I will start simply fixing stuff, because we have run plan that takes a seed, and no, we don't want a seed at this point. So this is where I will be taking all the idea of those seeds out, because that was a bad idea after all. So this will be for let db of plan DBs. Okay. There we go. No seeds. Just like we had before. For benchmark of benchmarks. Okay. And there we go. Got all that, and we run benchmark, and we don't provide it with seed. Great. So this is good. We don't have that weird seed anymore. And inside our thing here, we also don't do the thing for plan of plans. Bam. Run plan. Bam. No need for such things. Great. So where's the run plan? Oh, that was it. Run plan, and then we have run benchmark inside the benchmark runner. There we go. And by the way, our file finished, but I'm gonna finish that thing as well. I don't want the seed number because that's just a benchmark. Now, when we run the benchmark, we start the seed from some number, okay? Says the const initial seed is bum 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 bum. There we go. We got some random-ish number. Okay. So it's benchmark, timing results, run, and iteration seed, which will be the initial thing and the iteration number, and we just take it from here. Okay. And that's it, because each iteration then goes, you know, in proper order. So that's good. And why are we still starting that? So we've got for iteration, we've got our iteration seed. Okay. And here for its benchmark setup, mixed seeds, it will be just iteration seed. Sure. Good enough. And same thing here. Okay. And we're good. I think we're done with that. So let's take a look our select simple gen data. It says it's 75 megabytes only. Okay, that's not bad. I don't know why I expected more. It's just gonna be a lot of lines. Yeah. Organization, wrapping, folding, code lens, word highlighting, yeah. Yeah, it's a long file, but we've got create users, bunch of those, right? And they all have various numbers. Okay, that's good. Although with dashes, we probably need to wrap them in the special fun characters. So we're gonna do that, of course. And we've got they, deleted add none, likes, response to something. So most of them are responses, right? Yeah, well, this one is not. It's an this one's approved. We've got a paragraph, which is, well, plenty of that actually. Okay, that looks good. Bam, bam, all the new lines, new comments, and we have 100,000 comments. At least I would expect to. Yeah, because we can keep going and keep going and keep going. We're just barely at 100,000 lines. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines. So we have, yeah, 10 times more lines, right? 10 times, yeah, we have million, probably like million and something lines. So yeah, that's a lot. So I wonder what the database will do when we just run it. How could I import it actually? This is Surreal to memory. Let me just go to this thing. Right click. Wait, can I add new group or something? New group. So this group will be called, what is it? Homelander. This group will be, I don't know, Vision. Well, this one will be Java, because these are all on Java. So I'm gonna right click. Wait, they're already duplicated? No. Duplicate. Okay. And wait a moment. Right click, edit. So this won't be Java, this will be Homelander, because I wanted to work a little bit faster. Sure, that's all good. And this will be group Homelander, save. And this way I can at least see that I'm connected to this one. So Let's just quickly run the index, whatever, the schema. Okay. Bam, run. Namespace, of course. Namespace, wolala, database, wolala. Oh. What? Edit connection. This is connecting to Homelander, and it's telling me that the data is already here. This is weird. Okay, now it's correct. This one has tombstones. Okay, wolala. And database, wolala. Okay, so we run the query. Bam. And we're good. Okay, got our thingy. So now can I just, where's import? Say queries, query history. How do I import data? There's no obvious way to import it. Blah, blah, blah. Serving, blah, blah. No. Explorer. Here, import data. And I can just, can I just drag and drop it? Now let's just do import data. We should be in repos. Ooh, there's plenty here. Benchmarks, data, open. Are you sure you want to file? While exists data will preserve? Yes, start import. What database was successfully imported? Just like that? Users. There are no users. Comments. No comments. Okay, so this is, I guess, not a way I can easily import data. It needs to have, I guess, some specific format. Too bad. How many lines can I fit through that? Will it be fine if I'm gonna... Oh, I can't even select the whole thing. Control A. Copy. Can I paste 75 megabytes of text into this field? I pressed Control V. Let's wait until it reacts. Oh no, this might be one of those where it tries to render all the lines and syntax highlight them. Holy moly. No, it just refused. Control V refuses. Oh. It pasted. Yeah, 1 million something. Hey, it pasted in. It just struggles now because it probably tries to do syntax highlighting on it. But not bad. What happens if I'm gonna click run query? Sending it will be easy, encoding it will be not fun. What was a problem? Unexpected token. Yes, so that's the problem that I was expecting. See, all those are bad. They need to have their own weird little thingies. Let's just check what that thingy was. Because there's a whole, because we either could use backticks, but they are, we're already using backticks for other stuff. So data model, do we have something like IDs here? Record IDs. And do we have this character being displayed here? We have this. Oh, we have this one. There we go. Okay, great. So we close that. We literally delete that. Okay. We're gonna do, where is it? Select simple. And when we create the IDs, we have it in two spots. Create users, and the IDs are here. So we just put this in front of this one, and ID this in front of this one, and at the end we're gonna plop this one. And that should magically solve all our issues. Where is it? Here. Okay, We're just gonna run again to generate it, and hopefully it won't be that long. Okay, that's not too bad. Okay, you open it up, it loads. We've got nice everything. Control A, Control C, and we do Control A, delete. Wow, that was fast, and paste. Oh, okay, that was fast. It was like warmed up or something. I just can't click anywhere, but let's try to run the query. It's thinking. Okay, let's see. Wait, did I just... I got 101,000 responses. How about the errors? Record this, but expected option of record comment. What? Some of them got created randomly, but whenever we want to specify a record comment, it just refuses. Okay. Okay, this is a bit confusing, but expected this. Response to, oh, because I have them wrapped in quotes. I see. But in the meantime, we're gonna go to Explorer, user. We have 40 pages of users, so that's good. They're all generated. We have actual names, actual random emails, when they were created. And do we have at least one admin? Right? Yes, we have. How about comments? We have only 1001 pages. Okay. And that includes most of those that were, yeah, 25,000 comments here. Okay, that actually ran relatively quickly. That's surprising. Okay. So let's do this. We're gonna run one query. Oh, it actually started syntax highlighting the whole thing. Holy moly. Remove database. Wallala. Okay. Oh, this is struggling even here. I think because it tries to keep query history or something. Yeah. Query history. Actually holds it the whole thing here. Oh no. Oh dear. Is there a button to get rid of it? No. Oh well. I guess unless you have really powerful computer or don't mind lagging, don't paste in 75 megabyte long query into Surrealist. Okay, let's delete that and let's fix our issue. Because our issue right now is that when we have response to, response to was supposed to be just an ID, so we don't need those quotes around it. Yeah, 1,100,000 line query. Okay. So, I mean, that sounds absolutely stupid, and I love it. Did we have any other shenanigans like that? This needs quotes because this is this thing. Yeah, I think that's gonna be it. Because users don't have references anywhere. Okay, so we can just quickly regenerate it again. It takes surprisingly short time now that we actually write sequentially rather than overwriting it, because it probably involves all the nice buffers and whatnot. Great. So we've got another query. And now when I go to a little bit further, we can see that response to, and we have an actual ID. Beautiful. Copy, and let's just paste it here. Why do we have a different number of records now? I do not know. Huh. I wonder if we don't get it properly repetitive after all. That would be not fun. Okay, but for now, let's just try to run this query. We just... Wait, did we just get a response or not? Because this is thinking... Well, this is showing that the wololo does not exist. And all those exist. What? So even though I deleted the database, it just thinks they all exist? Okay, this is curious. Yeah. Oh wait, designer says this exists. Even though I run remove database. Oof, this thing is really struggling. So when you remove the database, it doesn't remove data? Oh, Surrealist is having problems. Refresh. Okay, it's connected. I'm gonna go to designer. Come on, it can do it. Doesn't mean there's no data is here, see? And in memory for the homelander. Okay. So I'm gonna go to query, new query, right? I'm gonna do oh no, now I can't type in. Edit R and it's thinking. Remove database wololo. Let's wait for it to realize that I pressed things. Okay, remove database wololo. Let's wait for it to realize I can click run query. This is really struggling. And return none. I'll go to the designer. It says no tables defined. So I'm going to switch to a different database, like this one, okay? Great. It's thinking. Let's connect back here. No table, okay? There's no schema, there's nothing. Explorer just says, hey, select the database. So I'm gonna select wololo. I know, maybe I haven't deleted it before, I haven't run it or something. I am confused. But now, in theory, I should be able to go and grab the index or the schema or whatever, right? Paste it in. Hopefully it's gonna work. Can I scroll up, please? Yeah. So we're gonna run this query. Accept it. Good. We click on the dangerous query number 3. Wait for it to load. You ink email? What the heck? Let me fix that in the meantime. There we go. Now it's a bit nicer. Okay, this query loaded, so let's try to run it and see what happens now. As far as I know, there should be no conflicts that something's repeated. Okay, this time it's thinking a little bit longer. And we already got our responses. And we're having problems. Error code out of memory. What? Am I out of memory? I'm using only like what? 40 gigabytes of RAM. Still have 50 left. I guess. Oh, because this is running probably on something like Electron or capacitor or something. And this has some separate memory limit. And probably the JavaScript environment crashes, or you know, this is like Chrome wrapped in something. And because of that, it probably has a limit of data per tab or something. And because we're not on, yeah, because this is a lot of HTML. Huh. So I'm gonna go to Explore. Wait for it to load. User. Okay, we've got 1,000 users. Perfect. Comments. We got 100,000 comments. Great. So that means I should be able to run queries, right? So I'm gonna just delete that query, okay, so that we can start doing things. Select. Will be something from comment. So let's say that I want to select only IDs. ID from comment. Where deleted at is not none, right? And deleted at is less than created at. And let's wait for it to realize that I wrote more text. Okay. So yeah, we want the records that have this, but I don't know how many it's gonna return. So let's see. Run this query. Okay, that returned quickly, and that is a lot of comments. How long it took? 283 milliseconds. Not bad for that many invalid comments. Okay, all right. So that's good. And on top of that, we want updated at is less than created at. So like super wrong ones. How many are like that? There should be still plenty, right? Okay, that ran a little bit longer because you need to process more. Okay, okay. But we still have plenty here. Okay. Table. Oh, this is just table. Doesn't show how many. Oh, it shows here. 1025 results. Okay. And author dot admin. Yeah, it's true, right? So how many of those 1025 are from admins? None. Why not? So, and admin is false. Well, I did capitalize, but okay, it returns nothing. How odd. We have defined author, right? Because I'm kind of getting confused now. User. Wait, author is a record. And this has, oh, is admin. There we go. Is admin. And we run the query now. And now we have 25 of those have all those criteria. Okay, this is getting better. This might work. I just really don't know how fast it's gonna be when it's not in memory, because right now I'm running it on a fast one with in memory. Not even like, you know, anything else. So this is as fast as we can get. But okay, this is good. I'll be able to start stacking all those things to get some kind of data back. Okay. All right. That makes sense. So can I do, instead of ID, it will be author dot name, comma, author dot email. So we'll see names and emails of all those admins whose comments have totally bad data. And you can blame that on them. Oh, this doesn't show it nicely, so combined. There we go. And there we go. Just like that. $25. Okay, great. So now that we have that, let's actually try to run it properly with a few queries. Okay, because now we can start actually benchmarking. It's 1 a.m. already. Holy moly. So okay, this goes well, so select simple. All this should work. Looks like we got an order. So now the idea is to have the queries. Okay. So here I define some queries. So this will be a bunch of queries. So it will be select invalid deleted at. Okay. And here we can just say this is a SurrealQL. Let's just put in a new line, okay? It shouldn't hurt too much. And we'll just do it this way, okay? So it'll be select ID from comment where deleted ad is not none and deleted ad is less than created ad, okay? That will be our first one. So I'm just gonna straight up copy this thing a few times. What the heck? Oh, because I did it that way. I see. So let's do it like comma. There you go. And maybe 4 times or something. So invalid add and and updated add. Okay. So we started with this. Then we also added on this one. Let's select very invalid. Select invalid, very invalid, very invalid for admin. From admin, okay. So an author is admin, right? So then I'm gonna have select very invalid from admin with whatever identity. So this will be the author dot name, comma, wait, author dot ID, comma, author dot name, comma, author dot email. Okay, we're gonna select all those three. I know that I could use some new features to do that, but right now we're trying to make it compatible with both new and old, with 2.0 and 1.54. Okay, so these are really simple queries. I wonder if we could just add another one that's a bit more fun. So we've got this thing. So let's say that we're gonna say grab all the comments from admins that have more than 400 likes. Okay. So let's just do ID. Okay, come on. From comment where we're gonna say author is admin. And what was I saying? Author is admin and likes is more than 400. And likes is more or equal to 400. What the heck? What? There we go. Okay. And then we can also add approved on top. Let's just see how many we're gonna get for this one, because I don't want to just send millions of millions or whatever. We're gonna go table. We have only 453 results. Okay, that's a good query. So we're gonna just copy this one. Ooh, let's just format them the way they're supposed to be. Okay, there we go. So it'll be admins with 400 plus likes. Okay. Then we're gonna have the same one, but we're gonna say that and approved. Okay. Admins approved with that many likes, and there we're gonna have one. How many are those actually? And approved, because that's not a lot. run. 123. Okay, that's good. So this is roughly okay. So we've got that part, that our admins are this, and then what could we throw on top? And response to index by author approved. And that are older than the author. Okay. And created at is less than author dot created at. So this will suddenly reach out with the, like a join on top of that, right? Because we have kind of one join here, and those two are considered a join, but not really. But yeah, how many are those? Probably small. 115. Look at that. So not too bad. So admins approved for likes holder. Okay, and we're just gonna plop it here. Oh, I didn't copy it? Seriously? Or copy stopped working? Okay, I guess we have those queries, right? So we have 1, 2, 3, 4, 5, 6, 7 queries to run. Okay, we're gonna try to run them 100 times each. Okay. All right. I guess that's it. So in our index, we are not doing the save to file anymore. Okay. So now what? I want to run it on all the devices at once. Okay. All of them. On Java, Translucent, Vision, and Homelander. The only thing is I need to run only that specific test, and we're gonna need to reset data before we actually do that. So benchmark will be select simple benchmark. Okay. Great. So that part's good. We got the benchmarks here. This should in theory work. All of it. Okay? All of it should in theory work. So how on earth are we going to do that now? So yeah, we just need to go on, and so the thing is that because as we accumulate data, especially with RocksDB or SurrealKV, it starts to work differently depending on basically the more data we add over time, it kind of slows down without proper time between and other requests going on. The storage layers work that way for some reason. So we need to go in and actually start all databases from scratch, fresh. So I'm gonna stop the Java, okay, and we're gonna go here to Java and wait for it to stop, and we're gonna do delete on all the data. Come on, Java, you can do it. And stop. Delete. I wonder if I'll need to in the future start running those things where Docker containers stops automatically after finished, and another one. Because I wonder if we're gonna stress the database and if the storage layer will be consuming any CPU after we stop requesting it, cleaning up or doing some other stuff. So one step of this whole benchmarking will be also to automatically start and stop all the containers as we need. So, and you know, create and delete all the data and blah and blah and blah so that we have things running properly. But for now, manually. Okay, we did that. We can start the stack. Great. It's gonna take a while. A long while. Okay. So that's good. So we've got all of those and we're running 202. Good. So we're going to Homelander now. And we're gonna stop it. And I can go here and delete the data. Okay. This guy is not connected anymore. I'm gonna straight up close him because just using up weird stuff. Great. And we can start the stack again. And bam, they're running. Now we're gonna go to translucent, another little slowpoke. Surreal benchmark. Okay, only KV is running. So we're gonna stop it. And let's just connect to it. All right. Our usage is okay. CPU system load, nothing, so that's good. So we're going to cd surreal, right? And we got our stuff here, so we're gonna do rm, rf, and star for everything. There we go. No more. Gotta love running rm, rf, right? Okay dokie. And the last one is vision. So we're gonna stop it. Alrighty. And this is okay. And for this one, I'm gonna just straight up remove data. Delete. Okay, we're good. Gonna start from scratch. There we go. Good. Okay, so they're all ready. We'll see if this is ready to actually send all that. Because the other thing is gonna encode all that data 4 times, send it 4 times, and we haven't tested the setup yet. Oh no. You know what? Let's just try to do it with just one that we have here for now, okay? And now let's try to run it. Okay, what just happened? Don't start. No such file or directory. Oh, that's true. So this needs to be benchmark/data. Not you, not you. You go away, all of you. Benchmarks/data. And let's run again. Okay, no follow directory. Select. Oh. Oops. I was supposed to add it here, wherever it is. Now, running version 0. Connected and signed in to the database. So now it's probably sending the data. And something tells me this is gonna run slower than Surrealist does. I don't know if Surrealist uses JavaScript or Rust to send and receive data. That's an interesting question. But here we're generating and sending it, so it's extra slow. So in theory, Homelander shouldn't send that data to itself. Although when it's sending it to itself, this isn't okay, it's good. Okay, this is taking much longer. Oh, because we're Surreal 1 memory. Okay. CPU is not upset. Memory isn't raising much. Can we get into the Docker stuff? Our Docker stuff. Containers. Serial benchmark. CPU. What? Oh. Huh. That went fast. What the hell just happened? These are like select very invalid. Okay, so they got cached. And they started going super fast. Huh, interesting. Because we got that. Select slightly invalid. Very blah blah blah. We run those. And then next iteration just goes blasting fast because it's all cached. Okay. I see. So we have some kind of caching implemented. That makes me very happy. That means we can run it only once. Because all the repetitions are pointless. And in theory, we should cache the query because this is taking some time, to be honest. But at the same time, it's good to see that something is actually returning stuff quickly. But I'm gonna let it run. Oh no, if it's taking so long, how long is going to be the, what do you call it? SurrealKV. Oh no. I forgot about that part. So you know what? We are going to cache the thing. Oh, we got the first thing and then it's bam, fast. Oh, we had just all those memory targeted. Okay, so that's good. So let's look at the results. The newest results. We have got, of course, raw, but then the summary. It shows 104 each, so everything is very, very, very small numbers. These are a little bit longer. Don't know why. But still, okay. I guess the most important here will be the first one. 147, and these are 413. Oh, that's why the number is a bit higher, because everything else is just nothing. Okay. So we know that we don't need to run it 100 times, because this is too little. I wonder what's the number of queries, how much it actually remembers. But for now, we're gonna make it, first of all, select simple, iterations 1. Okay, at least for now. We can change it later. But I'm also gonna make it let cached, not schema, those will be cached. Creation query. Okay. And we're gonna do this. So get creation query. Huh. We're gonna try to set it as 1. How about that? Because I think it's also slowing down because here we are trying to send it query after query one by one instead of just one gigantic request. So get creation query and still be function get creation query that will return a string. And if it's undefined, we're not reading from that. No. That query is nothing. Just gonna turn into an ugly string for now. I think that's gonna be just the fastest because it's 75 megabytes. We can do it, no problem. For let whatever some query of creation queries. No, what is it? What's the name of it? Generate data. We just need to pass the seed number. Ah, okay. So the seed number would be the different. I don't think we need to worry about the seed number here because this is for creation, so it doesn't matter. Yeah. Seed number. There we go. Okay, for this thing. Oh, because wait, generate data. It's a function. It's an async function, so we need async for a wait. There we go. Query plus equals subquery. Okay, there we go. And we save it, and then we return it. There we go. And we have that, and therefore, this is the generate data. So here we're just gonna say, oh no, this is a constant. That means every time we have this thing loaded, it's gonna build it. So let's do something like this. Async function creation query, blah, blah, blah. This is a string, and yeah. Yield. Hey, wait. Get creation query. Seed. Wait. Get creation query, so that will be a string, and we just yield it once, and that's it. Yeah. Good. Ay, ay, ay. Let's try it now. But we're gonna do it a little bit differently. So that was in there. So let's just see how much faster this is. This will be one thing to generate, the other thing to, continue doing things. And another thing is this is not like multi-threaded application or anything because it's all JavaScript. And it's not a lot of multi-threaded stuff to begin with here, so it could be multi-threaded, so no big deal. Yeah, just must be loading. And Docker shows that, okay, this one is using some CPU right now. Okay. And that's which one? Serial 1 memory. Okay, I see. So it's basically loading the data. That's what initially takes up a lot of time. It's funny how through what do you call it? Through Surrealist, it just goes so much faster. Okay, I did that. Finished. Sign into Homelander and Homelander. Oh, starting up while this one is down to 0%. Okay. So I mean, SurrealDB 2 is already receiving data in that case. We're not generating it. So that worked. We reused it. And the nice thing is that we will be reusing it for all instances for all the databases too. Okay. So the thing here would be that, oh, I see the problem. So the problem would be that if I'm running that benchmark somewhere, yeah, because I'm trying to send the data to several databases at the same time, if they're all the different devices. And that means that if I have 4 devices, the computer will try to generate it 4 times because the thing will be null by the time it's asking for it, and therefore it's generating and blah, blah, blah. So that's not great. Come on, how much time does it take to load it? It's so weird. This is in memory. This is the same thing that we were running with Surrealist, while it's just taking so much longer to load it. What does Surrealist do that is different here? Okay, that worked. Now we're good. Our test is finished. Okay, we got our new results. So summary here is this versus number 2. So, oh wow. Okay, so SurrealDB 2.0 is significantly slower at every one of them. How interesting. Even though the other Docker shows explicitly that it's not doing anything. So in running those queries, even the more complex ones, we still have, I mean, the more complex, the more overhead we have. Interesting. Okay, I think it's time to run it everywhere. The only thing is we need to pre-generate the query first. So let's do that. So we have the get creation query. I'm gonna straight up export that. Okay, this way in index, I can just say, how do I get rid of this? You go away. I'm just gonna say before we do that, we have the plan formed. Okay, run plan. So first of all, we're saying pre-generate and whatever, pre-generate data. So we do and creation query. Ay. So where's our benchmark? We hard-coded that ID somewhere, right? Generate data. We have chance of out of seed. Where do we use that seed? Nowhere here. These are the queries. Data gen query. Generate data. Oh, the runner. is getting the seed from somewhere, right? So where the hell was it? Benchmark runner. Initial seed. So let's do export constant initial seed. And that will be for iterations. There we go. So let's just do it here. Initial seed that will import from there, and this will import from there. Oh, wait. Console log pre-generating data. Done pre-generating data. And this will be basically starting benchmarks. Okay, so now that I know that everything works, I can uncomment all the other devices. Okay. And inside database, I can basically say, you know what, we're going to run it through all the other databases as well, including the not in memory ones, but the actual proper ones. And I really don't know why it's so slow when we're sending it from here. Because from, I don't know why the, what do you call it? Where Surreal is so much faster in submitting the same identical query. I just have no idea. Okay, so we're going to pre-generate data and then start sending it to all 4 devices, and we'll try to keep track on how fast things are moving. Okay. Great. We can get rid of this one and index. We have, wait, so in database, everything is enabled, including SurrealKV. Good. In index, everything's enabled, and only this specific benchmark will be running. So that's good. So now the only thing I need to do before we start is actually go here to Homelander, because this is where we're running all those against already. So we stop the stack. We remove the data and start again. There we go. So refresh. We didn't query any other database, so we should be good. Data will be pre-generated, so that's great. And yeah, I'm running it. We'll see how things go. All right, we're pre-generating the data. So in the meantime, I can, oh wow, pre-generation was so quick. We connected to 4 databases on 4 different devices. So we're going through RocksDB on each one of them initially. So now we're just uploading the data. Looked like we had a short spike in data being sent, or yeah, that was sent. We suddenly sent a bunch of data. Okay. Because in this case, we send it to, yeah, 1 over Wi-Fi and 2 devices, you know, 1 over 10 gig network, 1 over 1 gig network. So, yeah, that's good. And it's still sending it. What? And it says 32 megabits. What is, where is the data being sent? I do not understand. Is my stream down, or is that all okay? My stream looks okay. I just don't know why is but there's so much data being slowly sent. What? Unless I'm sending some kind of wrong data. Okay, we got some answers, probably from Homelander. Simple. Oh no, that was Java that responded first. What the heck? Huh? Why is Java responding? Translucent not responding. Homelander only now. What? The slowest device loaded data the fastest? Huh. That's funny. Okay. While this is running, because CPU is not like busy or anything, so that's fine. So while this is running all the things, it's gonna probably hang forever on SurrealKV for now. Let's just create a new sheet for, let's rename it to select simple. Okay, that was the name, right? Select simple. And I want to kind of copy the similar approaches we did here. So runs a simple set of queries, one after another, on a simple two table randomly generated data. Okay. And I'm not gonna put this query here because it's just a bit too much. We're just gonna focus on like creation. No, this will be purely something similar, like where we run one after another, right? So I'm going to do something similar, okay? Because we have this and we have that, and oh, this is blocking us. So let's just do this, okay? Up to here. Because we don't have 201 anymore, we have this and that, and we don't run two variants of schema less and schema full. This is a normal example, okay? So let's just plop it here, okay? Or I could actually just plop it here. There we go. Perfect. So let's figure it out. So we've got our devices and they are all... Let's just do this. Let's select those. Edit, find and replace, find space x50 and replace it with absolutely nothing. Bam. Okay. Okay. All right, and all right. Okay, so this is here. Devices are set. Now it will be the storage layer. I just need to correct it to the proper version that I'm testing it with. And now we'll have basically, you know, what is happening one by one. So let's look at our queries. Yeah, I think I'm gonna just create it like, you know, one row below, one row below. It's 3 rows below and 3 rows below. And how many queries do we have? So I'm just gonna grab this one. So we're gonna have name and then the value. Oof. Name and value. So slightly invalid. Okay. This one will be very invalid. What silly names. Then we're gonna have very invalid from admin. And this is the value. Okay. There we're gonna have very invalid from admin of identity. I'm just gonna paste it here. And that's the, come on. That's the query. We have just 3 more. Okay. And I know it's just linking from white to black, black to white, back and forth. Okay. And we have one more query. Perfect. And bam. Okay. This looks half decent. We can just do that to kind of stretch this a little bit. These will get moved here. And these are the queries. I'll format it nicely someday. For now, we just have a reference to just say slightly invalid. Okay. And I can probably just, whoa, what is it? Control Enter? Yes. Slightly invalid. Very invalid. Very invalid. From admin. Ew, this looks so bad. Okay, very invalid. Fits well. Good. Very invalid from admin with identity. There we go. Admins 400 plus. Let's just put that apostrophe there. There we go. Admins 400 plus. Approved. Folder. Yikes. What will that look like? Okay, I think we can make it work by doing this. Nope. This kind of good enough. So now we have, oh, that's it for now. Okay, so we can just clear those for now because we don't have anything here. Good. So that means we'll be able to start filling out data in here. And we'll use those to just calculate those averages and see how it goes. Sure. So how is our processing going? Oh, we're already at SurrealKV at some places. Look at that. So let's go to our modules. Data here, because this is ongoing. Okay. So we can start with Java, which looks like it completed everything already. I don't know how, but it did. So let's go. 1.0 RocksDB simple. We copy the data. And this is Java, RocksDB. Paste here. Okay, good. So this is our first result. And just keep in mind that this is like a one iteration. So this is not something where I'm running it multiple times because it's being cached. I wonder if reconnecting would change anything, but no, we were actually reconnecting between things. I guess we weren't. I'll need to take a look at that because remember we run queries like many of them and this is like very quickly. So I wonder if we were actually reconnecting, but we probably were because this is WebSocket and local, so no big deal. Okay, in memory, simple. 1.0. So that's here. Okay. What else do we have here? We have 2.0, RocksDB, RocksDB Java, bam. Okay. And then we're going in memory from Java. Okay. Okay, we've got those. I can just remove those numbers here because they are not present. They're just confusing us, okay? So we've got those results. Java hasn't completed SurrealKV yet. So we're gonna wait for that probably a little while. Where was that? Why is it so slow? Oh, that's probably on SurrealKV or something. Yeah, that's what it is. Possibly. I don't know. So we've got that one. Next, we're gonna go over translucent. RocksDB 1.0. There we go. Translucent here. Bam. A little bit faster in every aspect. Okay. Which is expected so far. For in memory, same story. Okay. It wins in, I guess, CPU. And the fact that it's on, on SSD, probably it doesn't matter. It's just faster CPU. And then we go, oh, we just got first result for SurrealKV from Homelander. So, wow, this laptop is struggling today. What the heck? Not sure why. Really struggling. So translucent, RocksDB for 2.0 now. Oops. Translucent here. There we go. Okay. Huh. It's just funny how it's not, I don't know, whatever. And in memory for 2.0. Bam. Okay. Good. So it's like 100 milliseconds. Oh no, here's more. But here's, interesting. Well, here's even larger difference. How odd. So that's that. So now we can go to vision, which is incredibly slow today for no reason. What? Oh, okay. Still on memory for that one. Weird things going on with this one. So let's do 1.0 RocksDB. Okay. Bam. I mean, it's less than half the time that the others took, so that's good at least. It's not like my laptop broke or anything. So then we go in memory. And we go here. Okay, that's in memory. Good. Next, we're going with RocksDB here. Okay. Still, same improvement. No, it's just so much slower to my surprise, but at the same time, 2.0 has just so many more features. Okay, so that works, and we just got result for the 2.0 in memory. Brand new results. Beautiful. So we can just plop it here. And did anything take extra long? No, I guess it was the creation that took so long. Very surprising. Nothing else added yet, so we can go over here and finish the Homelander. Let me start a Homelander. So 1.0 RocksDB. Okay. Then we go 1.0 in memory. All right. So far, no weird stuff going on. And then we go over 2.0 RocksDB. 2.0 RocksDB. There we go. Filled out. Then we go 2.0 in memory. Bam. Okay. And our first results from SurrealKV. Oof. Okay, these are not the numbers I expected, to be honest. And these are probably the fastest numbers. And the first query was the longest, I guess the one that returned the most records, while the other ones were roughly the same and sped up a little bit. This is very interesting. Huh. And did this calculate anything? This is calculating very wrong way. Average of those, please. Enter. Okay. And we just do that all the way down here. There we go. So get those averages. And now this thing is compared to this thing, right? This one compares this to this one. Okay, so that's good. And this one reaches out here. Okay. So on translucent, there's way larger discrepancy between for in memory and the other stuff. So how interesting. So Java, so when we compare the average number for, let me just do the thing where I can do view, freeze, no columns, but this will be, wait, first column. Two first columns? No, just one. This will be good enough, right? So we're taking right now comparing Java to 1.0 to 2.0 on RocksDB. Everywhere for Java, Vision, and Homelander, it's time that it took to complete something is on average 63% slower. Okay. But for translucent is 90%, so it's extra slow. And the same thing goes for in memory. And that's compared to this. So this result here for translucent on 1.0 must have been exceptional or something. Like one random one, because this is what? Double the time. What the heck? Don't know. Yeah, this is the thing. Double the time. Huh. Well, on average, we have this is being slower that much, and in memory is even more significantly slower. I wonder if it's due to this translucent thing. So I will need to find a way to run it multiple times, probably just literally run it multiple times and put in more inputs and just average it. I guess that will be the thing. On the other hand, I'm thinking that it will be fun to be able to put all this data into SurrealDB and just able to query it. But that's, that's for the future. For now, I'm fine with this. Let's just see if we got any other results in the meantime. Looks like we did, right? Okay, so SurrealV completed on Java. So let's put those numbers for Java. There we go. There we go. And you please be normal color. Okay. And like normal, what the heck? There we go. The translucent finish SurrealKV? Yes. I guess only vision is still struggling. How odd. Ooh. Again, translucent is so much slower here. So SurrealKV runs slower on translucent than Java? That's an odd one. Yeah, I'll need to find a different way because I'm worried that some of the changes that were written to, some of them are suddenly preventing, like because we first processed 1.0 and then RocksDB, this and memory and everything, that this is impacting how SurrealKV is running due to some resources or something. But at the same time, when I look at the thing, SurrealKV has 100%, and none of the other ones are using any other data. Huh. Interesting. So I wonder what kind of speeds are we going to get here, because we've got this that took 20 seconds, older, and I guess we have only one after that. Wait, that is older. Oh, so we completed this. Now we're just waiting for the data to be deleted, and that's the slow part. Oh, I see. Because now we're deleting, wow, a lot of records, so that's probably takes a few minutes. Yep. That's what's happening. And I am curious if SurrealKV will be using a lot of CPU even after we start with queries, because when I'm looking at everything, only SurrealKV is using, no, the RocksDB is using maybe 0.13%. They're all using very small amounts. But the both RocksDB use very small percentage. So let's also look here, because this just finished, right? The Homelander finished it first. So CPU on all of them is 0. Okay, so they're all calm and not doing anything. Okay. Okay, no complaints here. We just need to wait for the last one. Oh, it just finished. There we go. So we get vision results here. And we paste them in. There we go. Just a little bit slower than Homelander, just like with everything else, although here actually faster. This one is struggling. I don't know why. Don't know. It's 32 gigs of data and everything, so very confusing. And this, of course, doesn't have comparison, and it's, you know, 30 times slower than the rest. But hey, starting out, I'm really curious how those numbers are going to change when as SurrealKV develops. Because yeah, that is interesting. So now let's just reduce the number of commas on this thing so that it's readable. We can probably just do it into something like this so that it looks readable. And it would be fun if we would be able to fit that text a bit nicer, but it's not that easy. Some of that, but with this one, not a lot. Although we can just remove that period in there, and this one goes here. And this one actually looks like it needs to be expanded a bit. Okay, there we go. So yeah, these are our numbers. We got our averages. Everything works as it's supposed to. So the only thing will be to just add more runs. So I guess I'll be running that again at some point. And maybe one database at a time with breaks in between, just to see if that affects score in any way. And just put them in here, maybe average them together or something. I'll need to find a way to do that because, managing tables is just painful. So yeah, that's that. But okay, we've got some initial results. And again, this is with larger tables and whatnot and running in Docker, so it's not utilizing 100% of anything really. So yeah, that's that. And the goal will be also to basically add more queries here because our benchmark, simple benchmark, these are just simple queries. We could just do already so much more just with the simple data set. Maybe to start querying users and, from the user perspective, hey, find me all the like one of the queries that comes to my mind initially is, okay, will this one actually work? Oh, I don't have data on this one anymore. All got removed. But one of those would be, for example, something maybe more complex, like find unapproved comments on that are replies to other users, to some users' comments, right? Something like that. So we want to find, so when I think about it, we need to find comments of this user and find its ID, and then use that ID to get the comments that are responses to it and are also unapproved. Okay? Something like that. So yeah, instead of from comment, it will be from select from comment where author is whatever, hello, whatever, user ABCD, right? Although then we would need to have a user, huh? So that's that. And then we would basically need to say select value ID. Okay. And we would need to extract the first one or something. And then here we need to basically get the ID from this one where not really, because this is okay, this is a more complex query. It will be interesting. So I'm gonna add it as to do because it's late today. I need to go to sleep. So it'll be to do compare single query versus multiple step query performance. Because one could for sure define this whole thing as a single query, just like doing that, right? But there's also probably a way, like multiple ways to do with something like, let this and that and do this stuff. So yeah, we're gonna try that. Or I'm gonna try that later. Okay. I'm just gonna literally comment it out so that I have this thing here. Okay, there we go. So I'm gonna try that probably the next few days as I'm going through things, and I'm gonna add a bunch more, like a lot more of those queries, so that the benchmark, once it submits the data, it will be able to go over a lot of stuff. And this will be our first simple select thing without relations, without a lot of stuff going on, and that's the first step. So it'll be fun to keep adding those and running them from time to time. So that's that, and yeah, I guess that's it. So it's time for me to commit those changes. So what we're gonna do here, first one, yeah, I got updated, mix one schema. I'm gonna leave it here. Select simple, tombstones. Yeah, we just need to correct a few things. I am not putting this 75 megabyte file here. Delete it. And then we have a bunch of results. And some tombstones and some other stuff. I'm just gonna stage them all. Why not? Benchmark. That's good. Runner. Yep. And our index, which we will leave the way it is right now, because I think this is a good spot. And package and everything. Yeah. So stage all. And those will be end of stream 2. Select simple benchmark. There we go. Push it. And that will be it for tonight. All right. Or for many of you for this morning. All right. So I want to thank everyone for watching. I know it's long and slow, but that's how benchmarks are. You hit run and you wait for a few hours. Nothing exciting here. But yeah. Again, thank you for watching. If you like the content, consider liking and subscribing on YouTube or following on Twitch. And yeah, consider joining the Discord. Fun stuff there from time to time. Mostly me showing some random things. And see you around on Friday. We'll continue with SurrealDB, but this time in NIM programming language. We'll be continuing with the Seaboard protocol implementation, and I'm actually excited for that. I'm enjoying that. I was doing a little bit of that here and there, so a lot of tests and binary and whatnot, but it's fun and I'm excited to see it working. So again, thank you everyone and see you around.